Il volume al minimo, i passi al massimo e gli altri al minimo.
Sì, 1, 2, 3, 1, 2, 3, prova, prova. 1, 2, 3, 1, 2, 3.
Welcome. Okay.
Would you like to start first and then you can do that then? Maybe I think we might need to know when there's a break. Yeah. Refreshments. Yeah. Put the video during the refreshment break so that people can see it. Okay. Okay. I think that is okay. Okay. And then she'll just write.
Buongiorno a tutti. Possiamo iniziare se. I apologize for speaking in Italian, but we have a lot of people from Italy in the hybrid modality. So, allora, saluto tutti quelli che sono presenti fisicamente qui, ma c'è un altro centinaio di persone che sono collegate online a orari improbabili, perché c'è qualcuno che ci segue dall'Australia, qualcuno dal Brasile e altri dal Sud America, quindi non so che ore sia per loro. Questa è l'evento finale del progetto Interreg MONITOOL, un progetto che riguarda la fascia atlantica dell'Europa, quindi i partner sono tutti dalle Canarie alla Scozia alla Francia, però siamo stati inclusi anche noi, nonostante non facciamo parte dell'Atlantico, e quindi abbiamo avuto anche l'onore di organizzare la conferenza finale. Io non mi dilungo sul senso del meeting, perché ci sono molti colleghi che spiegheranno perfettamente di che cosa si tratta. Tra l'altro sono presenti sia online che qui fisicamente quelli che sono i maggiori, addirittura la professoressa Zhang dell'Università di Lancaster è quella che con William Davison creò i DGT una ventina di anni fa e con la quale peraltro abbiamo già organizzato nel 2009 la seconda conferenza internazionale di DGT proprio a Cagliari. Quindi ci sono illustri colleghi che spiegheranno qual è la possibilità di utilizzo di questi strumenti di campionamento, e online devo dire anche che ci sono dei colleghi che hanno fatto maggiori ricerche sulla possibilità di utilizzare strumenti per il monitoraggio di contaminanti organici, che comunque fanno parte della famiglia degli strumenti di tipo passivo per la misura dei contaminanti nell'acqua. Non so cos'altro dovrei dire. Mi sono dimenticato, perché sono un caffone, di portare i saluti del rettore e del direttore del dipartimento. Ovviamente noi siamo molto onorati di ospitare questa conferenza. Detto questo, io passerei la parola a Blanard White, che fa parte della DCU University di Dublino, che è il capofila del progetto. Quindi ci illustrerà lei in cosa consiste il progetto e che cosa è stato fatto. Il progetto è durato 6 anni, quindi è stato fatto molto, come vedrete. Please.
Thank you. Thank you very much. And on behalf of all my colleagues in MONITOOL, I'm thrilled to, not nearly as eloquently as Marco, but nonetheless to welcome everybody here today, both in person and online. Those of you who are online, unfortunately, you haven't had the opportunity to have Marco and his colleagues' fantastic hospitality. So before we go any further, thank you so much for organizing a wonderful event yesterday and today. And we have been treated like royalty since we came. So thank you very much. And for everybody who's online, we had enough food for all of you last night and we ate it all. So I would like to I have been on behalf of all our colleagues in MONITOOL to give you an introduction to what MONITOOL is, its findings and its impact. So over the next 10 minutes, that's what we will do. So the first component is to introduce you to what MONITOOL is. And we have, I should say, we have so many colleagues from MONITOOL online and in person, and I know we have a good discussion session later in the agenda. So I will identify some names of some people as we go through, and feel free then to follow up with questions when we get to that time. So what was MONITOOL? What is MONITOOL? It began for us in 2016 when we heard we were funded. And we were funded for, at the time, for 3 years, from 2017 to 2020. We had some unanticipated roadblocks, like a global pandemic in the middle. And then we were very lucky to have our project be extended so that here in 2023, we are still, the project is only now coming to a close. And we had 2 main objectives that we called out in that original proposal. The first being to allow the use of passive sampling devices in a regulatory context. And specifically, we were looking at DGTs to enhance the implementation of the Water Framework Directive. But we recognized at this time that how we would do that would be firstly to create a robust data set beyond what any of us individually were able to achieve of dissolved and labile metal concentrations in both transitional and in coastal waters, so that we could adapt the original environmental quality standards so that we would have suitable EQS for DGTs so that we could evaluate the chemical status from the data we would collect in that. So that was why we came into being in the first place. And I should say, with our amazing communications team led by Marta and Vanessa, we have multiple ways that you can follow us. So we're on Twitter, we're on LinkedIn, we're on Facebook, and we have our dedicated website as well, where everything we talk about today, you can find there. So please do take a look. They have done a wonderful job with it. We have 8 full partners. So as Marco said, I am from DCU, but we have representatives here, and you can see we are geographically diverse, representing the whole way from the Scottish Highlands down to the Canary Islands and here in Sardinia as well. So that gives us a geographical breadth and spread and diversity, which has been massively advantageous to the project. But in addition to the full partners, we have 10 associated partners, so that we are always engaging with our different stakeholders, our end users, so that what we are achieving, and you'll see, for example, online and in person, we have things like the good practice guide for the use of DGTs. If you're here in person, pick up a copy if you don't have one already. So that we are always focused not just on the science, but on how it can be translated, how it can be implemented. And so you can see we're the biggest European consortium working on DGTs. And you will see from the results as we go through those what advantages that has given us. So what was our original plan? Our original plan was, it looks very complicated here, but fundamentally to get to the end point where we could adapt, create adapted EQS for DGT. But by doing that through 2 huge sampling campaigns and a huge amount of common analysis, protocol development, and then a huge amount of analysis of this phenomenally big data set. And so in terms of how the project was designed, one of the key components for us was that we had individual partners do different aspects. And so this slide here is prepared by the colleagues who led out on this component from CFAS, so T and Philippe and Lee, where we look to define and develop protocols for sampling, for sample processing, for analysis. So we had our 2 field campaigns where we sampled in the wet season and in the dry season. And then the DGTs were all analyzed by Isabel and Jean-Louis and their colleagues, and Stefan in Ifremer. The seawater samples with Marguerite and Miguel and their colleagues in Portugal. And then we also, Stefan coordinated the DGT interlaboratory exercise. And you see we have a huge amount of outputs from that, which are all on our website. And then as we move to the extension gave us this opportunity then to update those protocols, to take our learnings, to iterate, to refine even more, and to carry out additional field campaigns, and to look again at those analysis again with Isabel and Miguel and Margarita leading out on those analyses, but also expanding, looking, for example, at biofouling analysis across those DGTs as well. So we had in total, I think 250 samples from the first campaign, an additional 150 from this. So you can see the robustness of the data that we collected, both from the original project and the extension. So what were our findings? So our findings, the first one, and this was where Maria and her colleagues in ASTI were instrumental, with colleagues like Herman who are here as well. In the first iteration, we developed a database, and that database allowed all the partners and all the samples to be collated in one coherent fashion that allowed for their interrogation. And we focused on cadmium, nickel, and lead. And creation of this database allowed us to explore different methodologies to analyze those metals in the different waters and to compare between them, and to see what relationships were there that we weren't able to explain just with environmental parameters, so we could explore in more detail. In the extension, again, similarly to the protocols, we improved the design of the database. And here's an example of the updated database that you can see. And we were able to incorporate the new data that was collected and analyzed and determined from the extension of the project as well, so that we were able to improve the linear relationships that we had observed initially, which was really important in terms of being able to then use it in terms of adapting EQS. So initially we explored untransformed data and then also log transformation, and found with the linear regression that we were able to see an improved linear relationship between the concentrations from the spot sampling and the DGT values. And you see here for cadmium, but we see comparable for nickel and for lead as well. So this data set, this manipulation and interrogation of data was only enabled because of the size of the database that MONITOOL enabled us to collate in the first place. And then Isabel and our colleagues in IFRMR explored how we can use this data and these analysis to achieve our overarching aims from the beginning of the project. And so how can we, on the basis of MONITOOL, how can we use DGTs for chemical assessment? And there are two options, and we have a paper that was published in the end of April, I think it was, so it's very new. And we have the version from the publisher and also open access version. So please do go and have a look and explore in detail. And Isabel and Jean-Louis is giving a presentation later today. And Stefan are all here, and we'll be very happy to answer your questions on it. But in short, based on the models that we were able to develop and explore, we presented in that paper. The first was to adapt the annual average EQS. With our data, we're able to adapt that to EQS for the DGTs so that you can compare DGT results to these adapted EQS. And that's the table that you see on the left. If I get my left and right correct, but also with the models, we can predict the metal concentrations and dissolved fractions from the models that we were able to create. And so you see on the graphs on the right, the green bars, which is the 95% confidence that the predicted for the prediction values within those regions. So in short, the extent of the data, the size of the database has allowed us to extrapolate and create these models so that DGT analysis can be compared to the EQS with the adaptations that Isabel and colleagues have led the MONITOOL team in developing, as well as to be able to predict what those metal concentrations might be. So what's the impact of that? So Marco sitting beside me and his colleagues have led out explicitly on the capitalization, where we are engaging with other projects with similar goals and explicitly developing a plan so that we can inform policymakers and end users around how to use them. And so we have presented from in Spain, in Italy, in the Netherlands, in Ireland, in the UK, and we continue to share and disseminate the information that we are learning here and to promote the framework. And one of the key ways that we promote the framework is getting back to what Vanessa and Marta and her colleagues in Gran Canaria have been doing with the website, where you see we have videos on how to use DGTs. We have the good practice guide. We have 7 scientific papers, and there are still some more being developed. The good practice guide, which again, like I say, is here. I cannot recommend enough how in plain language, and it is in already, I think, in English and in French, and the Italian version is in progress. So we are continuing to expand the reach of these really useful tools. So those are critical impacts for us. But I would like to finish with another impact, and this is what the human impact of MONITOOL, which has been phenomenal. And we said it's the largest consortium, but it's also the most open consortium I have ever worked in, where colleagues share their knowledge freely, where new people can join and are welcomed and learn and expand. So crucially, one of the biggest impacts, I think, of MONITOOL has been the creation of this European and beyond DGT family that is open and inclusive, where we share knowledge, train other colleagues in how to use it, so that we can realize the robust use of DGTs for all the reasons that we began with when we started this consortium together in 2016. So that is our whistle-stop tour. Hopefully it has raised lots of questions for you, but we are moving to have presentations by Professor Zhang, by Professor Gary Phones later, by colleagues who are joining us online, by Jean-Louis from IFRMR. So hopefully the questions that Natalia is going to give us a wonderful presentation soon as well. So hopefully your questions will be answered as we go through the morning, but if they're not, then we'll be delighted to explore them with you in the discussion session. So that is our introduction to MONITOOL. Welcome everybody, and I hope you enjoy this morning's session. Thank you. Thank you, Michael.
Thank you, Belenaid, and I invite you to speak, Professor Zhang. What is up to you?
Morning, everybody. It's a great pleasure to be here to see old friends and new friends. And first, I would like to thank. Oh yeah. First, I would like to thank Maria, Marco, and MONITOOL Group Committee for inviting me to be here. And my talk mainly focus on DGT as a research tool. Of course, DGT is a monitoring tool, but I will leave that to the expert of MONITOOL to talk about that part. So I want to focus on some research we have been achieving with DGT. So I look at its impact and on science and regulations. Okay, just for those of you who probably don't know about DGT, so I briefly introduce this technique. So DGT stands for diffusive gradient in thin film. So the most important component of this device is the resin gel taking up all the analyte you're interested and the diffusive gel. So because we have this thick diffusive layer, we can use Fick's law of diffusion to calculate the in situ concentration of any analyte. So because we know the amount being accumulated, this M, the thickness of the diffusion layer, of course, the gel layer plus this filter thickness. And then we have diffusion coefficient measured in the lab, and we know the surface area of this device and the deployment time. So we can get in situ time weighted average concentration. And I said DGT is a research tool because we can alter this resin gel, the type of resin and the thickness of the resin, and we can alter the diffusive gel. So we can design those research to fit your question, the purpose. So I'll show you later. And by looking at it, it's very simple, this device, and the calculation is simple as well. And we can get very accurate measurements. But as a research tool, it's not that simple. So I can show you later. And just a little bit of history about this technique. And it's invented in Lancaster in 1993 when I started as postdoc there, and patented in 94 after our first publication in Nature. And in 97, because we had quite a lot of demand from scientists wanting to use this technique, so we formed the DGT Research Limited by applying component devices to other research labs. And now it's become quite big. So we have more than 400 labs in the world, and organizations, not just labs, some organizations, companies, and using DGT. So it's these 400 labs over 70 countries. And the total publication peer-reviewed 1,500 in area of water, soils, and sediment. In 2014, we want to expand and to be able to produce better quality and more devices. So we established a clean lab in China, and now all the DGT devices are from China now. So this is just a map of the DGT users in different parts of the world. As you can see, there's a lot in Europe. And what DGT can measure, it can measure more than 60 inorganic elements and more than 170 polar organics. So here, of course, metals, and the type of DGT devices MONITOOL use is this colored in blue color is 100 kilax 100. This device can measure about 55 trace elements. And so the color code, this red is from one DGT devices. This blue from another DGT devices. Of course, we have devices for measuring gold, mercury, and other radionuclides, nutrients, and sulfide, and lots of organics. And of course, the development work still going on, and we're looking into not so polar organic, so POPs, PAH, and other pharmaceuticals. I just give you a list of this 170 organic compounds and with the publications. As you can see, the most recent one is antipsychotic drugs. So it's still the organic area still new. As you can see, this is the graph of DGT papers. I said over 1,500. Only 77, so it's sort of a new area for organic. And for the development work, also, sorry, I just gave you a breakdown of those papers in different research area. So I just want to single out this monitoring area. So in 2021 and 2022, we have 270 paper total publication, and water area 40, and those 40, 25 monitoring. So monitoring is increasing. Of course, there's several from MONITOOL contribution in that 25. And with the development of the organic DGT, what we normally do is, of course, we compare with spot sampling, and we also compare with other passive sampler, pulses and cam catcher. So we compare the sampling rate per unit. That's what other passive sampling use. So as you can see, that's the most recent work just submitted to Environmental Science and Technology, looking at a group of insecticides, 9 of them in groundwater and wastewater. So this is the comparison of DGT, pulses, and cam catcher. As you can see, with DGT is much more consistent and also bigger sampling rate per unit. Of course, if you just look at the sampling rate, these 2 devices has larger area. So DGT become disadvantaged in that sense, the sensitivity. So that's the next step of DGT developing bigger size. And yes, there's some review papers on organic passive sampling, and this most recent one. And as you can see, the conclusion, DGT is promising for future marine application, and it has a great potential for monitoring a large class of organic pollutants in marine environment. Okay, so now I want to focus on the research and just give you some snapshot of some of the groundbreaking research we have been doing, or the DGT community has been doing. So if we look at the application of DGT in water, mainly we look at the speciation and kinetics, bioavailability, and monitoring. Of course, I said for the monitoring part, I'm going to leave to the expert, and I'm going to focus on the speciation and kinetic and bioavailability, of course. And this is work recent, just published last year by a group of scientists in Germany, and they deployed the DGT in this Central Pacific at the depths of more than 5,000 meters to look at the speciation of trace metal and also the rare earth elements. So this table here, they are the concentration in nanomole per kilogram. And I just want to draw your attention on this highlights here. That's the average concentration of 3 replicate. As you can see, at such low concentration, DGT can still be so reproducible. And here are the blanks and very low blanks. And so the conclusion with this, they look at the labile fraction measured by DGT. In this environment, cadmium, nickel, vanadium, and is most labile. 70 to 100% of the dissolved, and including the rare earth element, they all labile, but copper and arsenic, they were less labile. And this work we have done many years ago, but the progress, we have made some progress, but not as big as in other area. This one is just showing you for DGT, when we change the diffusive layer thickness, we can measure the diffusive boundary layer, DBL. Diffusive boundary layer is on the surface of the DGT, depends on the hydrodynamic. You always have a layer of water, stagnant, and the transport controlled by diffusion. So that's why we call diffusive boundary layer. Normally, it's a physics, physical layer. Diffusive boundary layer should be physical layer. But when we look at the different elements for diffusive boundary layer, we notice, apart from zinc, cadmium, lead, the other metals have much higher diffusive boundary layer. So this gives us idea what's the contribution of this extra diffusive boundary layer. That must from the chemical dissociation, the kinetics of the complex dissociation. So based on that, and based on the model as well, the more complicated calculation, as you can see here. So this is a diffusive boundary layer caused by the kinetics. And we can calculate the dissociation constant, the kinetic constant of the metal fulvics and metal humics complexation. So why we want to do that? Because there's nobody else did it. This is the first one. And it is important. I don't know how many people knowing about the speciation model. So there's a lot of speciation model to calculate the speciation in the water. Rather than measuring, we do calculation based on the total dissolved. All those models, they are equilibrium model. They are based on the equilibrium constant. And more we recognize the kinetic is important for speciation. So the reason we don't have kinetic model, because we don't have the kinetic constant. We need constant to build a model. So this is the first step for scientists to use this technique to build a database of kinetic constant. So one day, some clever guy will come to, or clever lady, to build a kinetic model, okay? So as you can see, our measured constant based on DGT is agree well with this theoretical constant, eigen constant. Okay, so I said the progress here is not as big as other area. And there's one group in Spain, Professor Joseph Gaceran, sorry, every time. Professor Joseph Gaceran and Jaume Puy, and together with a group in Belgium, Professor Yue Gao and Willy Bayens, they have been working in this area. So there's some papers from these two groups, you can have a look. And so DGT as a research tool have applied in soils and sediment. Just briefly show you how DGT work in soils. It's not like in water, it can keep constant resupply of the analytes, maintain this concentration at the surface constant. In the soil and sediment, the concentration at the surface of the DGT depletes. Of course, some pessimistic people will say this is not good technique, but optimistic people will say that's fantastic because this can give us the insight how the solution solid phase interact and their labile pool size and their kinetic constant again. So we can build a model. And also, if you think a plant root or animal in the soil and sediment, they take metal nutrients, they deplete the concentration there. So it's kind of, we thought, okay, this technique could mimic the plant and give us a bioavailable fractions. Okay, to test that, we grow lots of plants, we deploy DGT, and we look at the metal in the plant and metal measured by DGT. And you can see we have really good correlation, linear correlation for different vegetables, different plants. Of course, there are always exceptions, like a potato will not be able to be predicted by DGT, but other leafy plants seems works well. And as I said, we could build model, and together with DGT measurement, we can obtain the labile pool size, how much available in that soil or sediment to biota. And we can look at the kinetic dissociation, how fast it can resupply to this uptake, to this diffusion. So we build this model called DIFFs, and it can combine with DGT data to do the calculation. And now just briefly, DGT research in sediment. So we have different configuration now. It's a rectangular probe with the length of 15 centimeter. And we can put this probe into the sediment rather than taking the sediment core back to the lab, which you change the sediment properties. So this all in situ. After a certain of time of deployment of DGT probe in the sediment, you have different ways to analyze it for producing this high resolution 2D image of the analyte, like a fingerprint. So a more basic way is you get the gel out and slice into different, into small pieces, and then you analyze those different pieces, and you construct this 2D image. Or there's some analyte like a phosphorus, and you can just do a color development, and immediately showing you which part it has a high phosphorus, which part have low phosphorus. So look at a hot spot, and also sulfide can be used this way as well. And more sophisticated, using laser ablation, ICP-MS, to get a really high resolution of the distribution of metals in the sediment. So that's this high resolution gave us insight of the biogeochemical processes at the level those bacteria and those microorganisms working. So rather than in the past, we have 1 centimeter bulk measurement, so we can zoom in to see how things work in those environments. And this just gives you an example what we can do. So this is in the paddy field, in the sediment, look at the roots, the metal behavior around the root zone, rhizosphere. So this is the oxygen distribution at this root tip, and these are the DGT measurement of different metal. As you can see, cobalt, manganese, and zinc and nickel, they're the nutrient for rice. Sorry, I forgot to mention this, the rice root. And so they have, you can see the depletion of those metal around the root zone. But then those contaminants, this toxic metal, arsenic and lead around this iron plaque. So because when the oxygen into the root tip and it oxidizes the iron. And there's lots of work saying, and when iron being oxidized, it's lock up all the metals. So all the contaminants, toxic metal is not available to the roots anymore. But this work shows the opposite. The reason we can see it because we can zoom in, we can see at such a high resolution, as you can see. So when the iron oxidizes, the arsenic, we have a high iron there, and we have high arsenic as well, and high lead. So what's going on? And if you think how the root works in the soil, it has vertical uptake, taking up the metals, and it has this oxidation, iron oxidation. And with iron oxidation, if you write this chemical reaction, you can see there's a lot of acid produced. So there's another process is acidification. So it depends on how much acid produced. So this acidification can remobilize those toxic metals. So that's just something we see with such a high resolution measurement. So now we move those technique into the organic research. Okay, so far there's 77 papers, most of them are method development. So gradually we're using DGT for organic research to look at the processes. As you can see here, that's recent work as well, and just submitted to ES&T. That's the antibiotics in a lake sediment in China. As you can see at such depths, we can still see some antibiotics in those environments. Of course, China uses lots of antibiotics because it's not by prescription. You can go to the counter to buy antibiotics, so you can see the impact of that. Okay, just summarize the DGT impact. And we have made some big steps in science. And we certainly made the first step on solid ground for regulation. Of course, the star is MONITOOL in this area. And in China, Australia, and New Zealand, the government has been adapting this technique for some of the standard method and guidelines for water, soils, and sediment. And looking at other impacts, so it's a big impact in monitoring in different environments. And the forensics, so some, at least in China, the police has been using this technique to look at illicit drugs in water. Precision agriculture in Australia, DGT has been used to measure phosphorus, to advise farmer how much phosphate fertilizer to apply on the land to make sure they have a good crop. At the same time, not too much to contaminate the environment. So this has been well established. And high quality aquaculture for fishery. And NIVA in Chile, they have been using DGT to look at the metals, antibiotics in their fishery for water quality control. Of course, risk assessment for some water treatment and soil remediation to use DGT, look at the resupply, the availability of contaminants after the treatment. And of course, new standards and new regulations, and we're working on. And still, there's a lot of work need to be done. And you can have those cutting edge research in chemical speciation, including the nano-colloid species and bioavailability. Lots of work done on soils, but not many in waters. So that's a big gap there. Toxicity, of course, almost none. So that's a big area to go in. And dynamic models, so using DGT to obtain kinetic parameters in waters and in soil sediment to build models. Of course, with high resolution measurements, combining with other technology, we can look into the details of biogeochemical processes, hopefully making more advance in this area. And the rhizosphere processes, like I showed the rice root, and there's also other roots can look into, a new type of the DGT, and there's always some new method, new development. Okay, finally, I would like to invite you all to join us at 7th International DGT Conference in October this year. It's organized by Dr. Gorney and Fev here, and in IRSN near Paris. So because of the limitation of this meeting room, we confined to 100 participants. So if you want to join, please register as quick as possible. And the deadline for abstract is 31st of May. And even if you are not so interested in DGT, at least come to this dinner. So we're planning to go to Ciel de Paris, and this is the view from that restaurant. Okay, thank you very much.
Thank you. The next speaker is Natalia Montero from ASTI, Spain.
Buongiorno a tutti. First of all, I would like to thank to the Marco and organizing for being the host of this final event. And already Blanet and How they have provided some insights into the MONITOOL project and also the use of DGTs. So this presentation has as an objective to provide you some guidance from the moment that you decide to use DGTs till you get your results, and then you are able to assess the water quality in the marine environment. So this presentation is meant to be quite dynamic. So if you want to interact with me at any point, and also I'm talking to the students now, se volete anche interrompere, parlare o fare delle domande in italiano, le potete fare. In italiano e inglese va benissimo, quindi let's go. Okay, so first of all, when you decide to use DGTs, of course, you have to know what is the objective or what you want to assess. So like that, you can plan the sampling strategy. And in this case, you have to know, I mean, how many stations you want to monitor, especially if you want to have a high or a lower spatial coverage, depending on your objectives. But also the number of sampling campaigns you want to perform. For example, if you want to see differences between dry and wet season, and so on. So here I'm going to show you some examples. Like for example, here on the top, it's a study that we did in the Basque Country, and we covered 12 estuaries that we have there. And in this case, DGTs, because it's a technique that you can use in any kind of environment, both freshwater and also marine water. In this case, we deployed DGTs, for example, in the Oligoalin stretch, that it's the moment where the estuary starts, and then in the Eualin stretch. So like that, you know what are the contaminants or the metals in this case that are coming from the river, and also the ones that will be leaving the estuary and reaching the coast. But also they have been deployed in different occasions, for example, to evaluate the effect of dredging and the dispersion of contaminants. And also it can be used like in this case, like if you put several stations and you do a high spatial coverage, you could investigate what are the different sources, point and non-point sources of contaminants entering your marine environment, in this case, estuary. So as previously said by Blanet, different guides and protocols have been published on the framework of MONITOOL, and all of them are freely available. There are also very nice videos done by our colleagues from IFREMER, where they explain step by step how to use DGTs and the different steps, how you have to do the laboratory work and also the field sampling campaigns. And you will see that in these guides, you can find this kind of like graphs, where you can find all the information about the type of information you need, all the materials, all the methods, step by step explained. And you will have all these presentations available afterwards. So you can go directly to these guides and also the tutorials that are available at the MONITOOL webpage. And you can check there all the different steps. So this is Digitis, as how the mom of the Digitis presented us. So I'm not going to go into detail about that. And then this is the kind of laboratory work you have to do before deployment. So here you can see that we have these plastic structures where we put the Digitis. And then we also, usually we use this kind of nets to avoid like the fish. They eat, like sometimes they go for the membranes. They like that they are white and very shiny. So they go for the membranes. So we use this kind of nets to protect the Digitis. And then as you can see, it's like a normal sampling equipment you carry to the field. So there's not so much additional work involved if you would like to use these Digitis instead of doing normal spot sampling or traditional spot sampling. Here you can see like everything is like in acid wash double bags. And we ship like that to the field to ensure that we are not contaminating our samplers. And this is the kind of deployments you can think of, but of course you can be also creative. All of us, we have been there, so everything works correctly. The only things to take into account is where you deploy Digitis. Of course, you don't want them to be very close to the sediment because then you won't be monitoring the quality of the water column, but more all the contaminants that maybe are released by sediments. And also we try to avoid, as you can see here, we try to avoid the first meter and a half, because it's the water that is changing more quickly. So you want to be more or less in a stable environment. So you are really representing your water column. And here you can see that there are different kinds of deployments. So Digitis, they are quite versatile. You can deploy them in a lot of kind of structures. And here you can see like some examples, like using, like using like pontoons in the harbor. You can use buoys. Sometimes we use them like the ones where the docks for ships and so on. And here, like there are, you can do it from from the ground, from the bottom, or you can do it from surface. That usually we use more this kind of structure because it's easier to deploy them anywhere. Okay, so the day that you are deploying them and also the day that you retrieve them, of course, you have to measure all the physicochemical parameters. You will see later on why, because you will use some of this information for your calculations. But you will see that is quite straightforward, so nothing to get scared about. Oh, sorry. Yeah, and this is so you measure here all the physicochemical parameters. These are your Digitis after the deployment. So you see like they are quite protected by the net. Then you take your structures, you put them back into these bags that they were already clean. So you are ensuring that you don't have any kind of cross-contamination problems. Also here you will see that every time that we deployed, every time that we deploy Digitis and also at the retrieval time, we use blanks to ensure that we are not contaminating them in the time that we are processing Digitis. So this is like an extra control that you don't have usually for water samples. So we do it both for the lab and also for the field part. And once again, you carry your Digitis bags into the laboratory in a fridge. Once you are back in the laboratories, you are not going to perform your analysis directly. You just dismantle the structures, you put your Digitis back in single bags. And this is how you do the extraction. You could see like here, yeah, I think it's a bit difficult. You could see that there is a colleague with a screwdriver. Of course, you have to use a glove to ensure that you are not contaminating your Digitis with metals. You just use the screwdriver, you put it, there is like a little hole where you can insert the screwdriver, then you do like a click. So it gets open, you extract the resin, as you can see in that figure, and then you put it in a tube with some nitric acid, 1 molar nitric acid. So as you can see, it's quite an easy process. And also because the metals were accumulated during the sampling time, you don't have to do any pretreatment. So from here, you can go directly to the analysis, in this case with a CFAS, ECPMS, but you could use any other kind of analytical technique for measuring metals. As I told you, and this is the important part, the most important parameters that you have to be sure of noting down are the deployment time, because it's one information that you will have to use for your calculations, and I will show you afterwards, and also the temperature, because as How explained to us, it will affect to the diffusion of metals in your DGT. So you need to calculate what was the mean temperature during the deployment time. And for that, we use the temperature you measure at the beginning when you deploy them and at the retrieval time. So here I'm not going to go so much into detail, but I just want to show you that there are two equations you will need, but they are quite easy to do. So as you can see here, the things that are marked in red, those are numbers that you already know. So they are things that we use the same numbers for these calculations. Here you move from the concentration you measure in your evaluate with the ECPMS, let's say. Then here you use the volume of the gel, that is a constant, and also the volume of nitric you use for performing the elution. And then finally, we use this factor that it's an elution factor, that it only means like, for example, if you accumulated 5 micrograms of cadmium, let's say, how much then you are going to be able of extracting with your nitric acid. And that we also use a constant, because we know like using a 0.8, we know we are covering all the metals like quite nicely. And afterwards, once you have calculated the mass of metals that have accumulated in the resin, you will go to calculate your concentration in the water during the deployment time. As you saw before, DGTs, you deploy them, let's say for 4 days, but you could deploy them longer or for shorter time, and they will be accumulating all the time. So at the end, what you are going to get is a concentration that is integrated in time. And for that, you will need this equation. And here you put like the mass that you are taking it from this equation. Some parameters like the diffusive gel thickness, that it's a constant. Here, as you see, you have to put also the time in seconds, and that's why you need to know your deployment time, and also the diffusion. And for that, Lancaster very nicely, they have performed a lot of studies, and we know how metals behave, or what is the diffusion of metals depending on the temperature. So this is something that is temperature dependent and also is different for each metal. But at Lancaster's webpage and also in our guides, you can check what are the diffusion coefficients for metals. So I just want to show you how we do it, so you realize that it's not a complex process. So here is, for example, an example. We have separated them by colors. So here you will see that there are 5 stations. In this case, we use 4 replicates, but it will be enough also with 3. The good thing of DGTs is that they are quite a cheap technique. So that allows you to have replicates at each station and to detect if there are any kind of outliers. It's not like you are going to the field, you collect a water sample, and then what you measure is what you have. So you cannot know if there was any kind of contamination, if maybe you didn't go in the correct moment. In this case, having the replicates, I will show you afterwards how it gives you this security that you are really measuring what was in the water at that time. Okay, so here you see, this is what the ECPMS you will measure in your evaluate for each of the replicates of each station. From there, you will move to the mass with the equation I showed you before. Here, of course, time is very important because it's one of the parameters that will be included in your equations. Diffusion coefficients that I already told you, as you can see there, that is temperature dependent. In this case, it's for lead, but there are different diffusion coefficients depending on the metal, but these data are all available. And at the end, we calculate what is the concentration in water. So you will have a concentration for each of your replicates. Of course, as I told you, the good thing of DGTs is like it's easier to detect your outliers. So you will see if you had any problems or any of the replicates was contaminated or didn't accumulate correctly or whatever. So in the guide, you will see that usually we use variance coefficient, a coefficient of variance percentage of 30% as a threshold. So what we do, as you can see here, is, okay, so we calculate the coefficient of variance for your replicates for each of the stations. And when you go over 30, you realize that there you had a problem. As you can see in the fifth station, the one at the bottom. So what you do is you remove the replicate that is giving you like these outliers or these strange results, and you see like easily you can detect the outlier and you can correct it. So you have a concentration that represents clearly what was in the station. And then how we move from, okay, now I have a concentration, but what does it really represent? Because at the end, we only have a number. So we work hard for publishing this paper that it was published like 1 month ago. And there, leaded by our IFREMER people, we develop environmental quality standards for DGTs. So these are guidelines, there are thresholds that you can compare your results with. And like that, if you are over these results, you could say, okay, we are going to have a problem in this station with this metal. These metals are the priority metals in directives, so are the ones you are enforced to measure in all the member states. So we have to report this data for spot sampling to Europe. In this case, we're proposing DGTs as an alternative to spot sampling because we know it's not the best technique for dynamic waters, that they change very fastly. So here are the guidelines we developed for each of the metals, and I'm going to give you some examples with data we had from the past, so you see what they really represent. So for example, this is a study we performed in Pasaya, like it's a estuary in the Basque Country, and we had 11 stations, like all along the estuary, from the inner part of the estuary till the coast, like here is already the sea. And these are the values for cadmium. Okay, so you will say, okay, I'm having like, I don't know, 0.2 micrograms per liter of cadmium. And before we didn't know what that really represented, but now we can compare them with EQS. So as you can see, once we do that, we can clearly separate the stations and we can detect in what part of the estuary we might have a problem with that metal. So you can see that in the upper part of the estuary, cadmium values are over this threshold. So probably means that in those stations, we might have a problem with that metal that potentially could have effect on your biota. Let's do the same for nickel. And as you can see, in this case, we had also in these 11 stations, but we have results from 3 different seasons. So we did it in summer, we did it also in winter and in autumn. Because I told you here, we wanted to have a high spatial coverage, but we also wanted to see if there was a change in the estuary, depending if it was a wet season or a dry one, because we know that there are some problems with the runoff of metals to our estuary. And as you can see, if you compare these concentrations, like it goes up to 0.6 microgram per liter, they are far below the EQS. So you can say that nickel is not a problem in this estuary. So you are not expecting to have problems related to this metal. Okay, and finally, I will show you the sample for lead, where you can see why DGT is a nice technique for this kind of studies, because you will see that we can see even differences just sampling the same estuary at different seasons. And thanks to the reduced price and the reduced things that you need to do to get this kind of results with DGTs, you are able to get a good coverage of all the processes going on in your estuary. So here you can see, okay, this once again, the threshold. And as you can see, for example, in summertime, we see that lead has high concentrations in the stations that are in the inner part of the estuary. On the other hand, you can see that both in February and November, so when in the Basque Country we have rain and runoff, we can see that lead is not anymore in the inner stations. You are not going to have any problem there because it has been washed off to the lower part of the estuary. So you will find it more in the stations that are here inside the estuary because it has been washed off from the river and maybe all the input from the cities, I mean, the urban nucleus that are around these stations has been washed off to the lower part of the estuary. So yeah, this is like a bit the kind of information you can get with DGTs. So now I'm open to any questions, if you have any. Anche gli studenti potete fare le domande se volete.
Se non ci sono domande, I think it's Jean-Louis Gonzalez.
Monsieur. Hello. Thank you very much to the host for giving me the. Oh, yes. Sorry. It's okay like this, yeah. Thank you very much to the host to give me the opportunity to make this presentation, and special thanks to Unica team. Thank you. And thanks to everyone to be here today. It's also a big pleasure for me to be among my friends and colleagues from MONITOOL project, maybe MONITOOL project. As you know, there is a wide variety of chemical contaminants, often at trace level, which are very difficult to analyze. For metals, as you will see throughout the day, the DGT technique fix the problem quite well. But what's about the other contaminants? There are many passive sampling techniques adapted to different families of contaminants. Polar organic chemical integrative samplers, just some examples, it's not exhaustive, okay? Polar organic chemical integrative samplers for hydrophilic contaminants, stirba-sorptive extraction, but equivalent technique in integrative passive sampling version for organic contaminants, hydrophobic organic contaminants, and SPMD for organic hydrophobic contaminants too. For illustrative purpose, a large-scale application that we carried out in very, very different sites, rivers, bays, marinas, harbors, traditional waters, and so on. And we carried out using 3 different techniques: DGT for trace metals, POSIS for hydrophilic contaminants, and stirba-sorptive extraction for hydrophobic contaminants. These campaigns have made it possible to acquire data in very, very different environments. The concentrations of contaminants were measured in over 300 different bodies of waters. The results obtained revealed the presence of certain organic compounds at very, very low levels, less than nanograms per liters. More than 200 different chemical contaminants were analyzed. And a very important point is that the initial campaigns were accompanied by training activities for the implementation of these techniques. Many people were trained across the various sites. Just an example, the use of the 3 techniques for one site is the equivalent to the sampling of several dozen liters of water, and without the steps of filtration, extraction, concentrations in the labs. If we compare to conventional techniques, the steps you must do in the field, sampling, filtration, using ultra clean techniques, and in the lab, extraction, concentration steps, and analysis. As you could see, passive sampling covers most of these steps. Another example, for 7th station, the sampling for the measurements of many contaminants in triplicates represent a very, very small volume, which is possible. This volume is possible to transfer this volume of samples in the aircraft cabin. And I do the calculation, in this box, you have the equivalent of 200 liters of water. This technique can be implemented in a wide variety of aquatic environments and is adapted to the use of many means of intervention. The implementation protocols of these techniques are very easy to transfer to non-specialist operators. These methods can be implemented with very limited logistical and lab resources. Many other applications are possible. Environmental impact studies, accessing the occurrence and levels of emerging contaminants, speciation studies, and etc. As an example, and very briefly, sorry, Marta and Vanessa, but you can read the paper. It's a very nice paper. An application developed with my colleagues at the Instituto Tecnológico de Canarias. And the objective was to demonstrate the usefulness of integrative techniques in dynamic systems. For example, in the case of wastewater discharges. And following the MONITOOL methods, the main conclusions of this study are the robustness of this technique and the advantage of integrative measurement in dynamic system, because the spot sampling can miss some peaks and may not properly monitor the wide variations in the total dissolved metal concentration. Another question, is passive sampling more expensive? These techniques require two field trips, one for the deployment and another for recovery. But decrease the preparation time for sampling, filtration, equipment, and no filtration and extraction concentration operations. And this is done in situ and doesn't require highly qualified staff. Decrease the volumes of reagents used. But for analysis, we use the same techniques in passive sampling and convectional techniques. Let's go back to the first question. What's about the other contaminants? New method, the method evolves, and thanks to the new configurations of DGTs, the range of compounds and species that can be analyzed by DGT has been expanded in recent years. Molte grazie per la vostra attenzione.
Grazie Gianluigi, senti Gianluigi. Credo che Gianluigi Gonzalez sia quello che ha messo più DGT nel mondo, partendo dalla Polinesia fino a Mariotte, e fa un lavoro invidiabile. Il prossimo, allora noi abbiamo aperto questa conferenza anche a colleghi che si occupano di tutt'altre cose, per avere la possibilità di vedere, di capire quali potrebbero essere altre potenziali utilizzazioni dei DGT. Quindi adesso sentiremo la relazione della dottoressa Laura Durante, che dirige il parco, dal punto di vista scientifico almeno, il parco naturale di Molentargius, che è una zona protetta, dove ci sono uccelli, fauna e flora protette a Cagliari. Adesso ci spiegherà lei meglio in che cosa consiste e vedremo qual è la possibilità di utilizzare i DGT in questo contesto.
Buongiorno a tutti, ringrazio tutti quanti e soprattutto Marco di averci dato la possibilità di partecipare a questo incontro estremamente interessante. Come vi accennava Marco, io sono una biologa e lavoro nel parco Molentargius Saline. Il parco è una delle aree umide più importanti d'Europa per quanto riguarda la nidificazione di diverse specie estremamente importanti, come per esempio il fenicottero. Abbiamo il maggior nucleo riproduttivo di fenicotteri di tutta l'Europa. Quindi è una zona di estrema valenza, ma ha una caratteristica fondamentale del nostro parco, che è un contesto estremamente antropizzato, cioè il parco è completamente circondato dalla città di Cagliari, di Quartu e quindi tutto l'interland cagliaritano. Vedete, questo è soltanto il poetto. Quindi la pressione antropica a cui sono sottoposte le acque del parco e tutto il territorio del parco è estremamente importante, e questo ha fatto sì che noi siamo un elemento distintivo è il fatto che all'interno del nostro territorio abbiamo diverse aree che sono contaminate da composti chimici di diversa natura, sia composti per esempio dai metalli pesanti, di cui oggi vedremo maggiormente il dettaglio. Questo è il territorio del parco, come vedete è un'estensione abbastanza importante, sono circa 1600 ettari, di cui oltre 800 ettari sono acqua salata, acqua dolce, e poi all'interno del parco abbiamo un impianto di fitodepurazione, che è questo che vi sto facendo vedere, che serve per alimentare gli stagni ad acqua dolce del parco, cioè queste aree vengono alimentate e tutte queste aree qua vengono alimentate dall'impianto di fitodepurazione che riceve le acque da un depuratore consortile che è posizionato qui e che tratta tutti i reflui dell'Interland di Cagliari. Quindi noi abbiamo necessità quindi di valutare quelle che sono le caratteristiche del nostro ambiente, e all'interno delle attività che noi effettuiamo molto importante è il monitoraggio. Come parco noi monitoriamo sia le acque sia i sedimenti, monitoriamo anche tutto il biota bentonico, monitoriamo la fauna, sia l'avifauna sia l'itteofauna, la vegetazione, e per quanto riguarda le attività di monitoraggio collaboriamo anche con università di ricerca, associazioni, eccetera. Molto importante è che tutte le attività di monitoraggio nella matrice acqua e nella matrice di sedimenti e del biota bentonico utilizziamo i protocolli di campionamento e anche i metodi e le metodiche di analisi che sono previste dalla direttiva quadro sulle acque. Quindi da quando è stata disponibile ci siamo subito immediatamente adeguati a questo tipo di indicazione. Infatti il monitoraggio in un'area protetta come quella del Molentargius, che tra l'altro oltre ad essere un parco regionale ha all'interno anche 2 siti della rete Natura 2000, forse magari è utile ricordare che la rete Natura 2000 è un insieme di aree che sono estremamente importanti per la conservazione della fauna, della flora e degli habitat, che è istituita a livello europeo e che dalle direttive ed è normata, diciamo, dalle direttiva Habitat, che è una direttiva comunitaria appunto che gestisce, che ha istituito le aree Natura 2000. Quindi tra le aree protette bisogna ricordare che sono state anche indicate in un registro che è sempre istituito ai sensi della direttiva 2060, e all'interno delle aree protette sono ricomprese quelle che sono designate per la protezione degli habitat e della fauna e delle specie, quindi anche quelle che noi siamo all'interno del nostro parco, quindi rete Natura 2000, come vi dicevo. Ci sono diverse indicazioni, il manuale che è stato prodotto per esempio dall'ISPRA, manuale di gestione di siti Natura 2000, dà delle indicazioni sulle attività di monitoraggio. Qui molto velocemente vedete appunto il manuale, e questi sono alcuni, soltanto alcuni dei parametri che poi noi andiamo a determinare all'interno cioè nelle nostre matrici, nelle acque. Ma qual è la caratteristica principale che deve avere il monitoraggio in un'area protetta? Il monitoraggio in un'area protetta deve essere fatto in maniera tale da recare il meno disturbo possibile alla fauna. Quindi noi non possiamo effettuare dei monitoraggi che per esempio mi fanno spaventare, scusatemi il termine, i fenicotteri che abbandonano i nidi. Quindi dobbiamo effettuare monitoraggi in maniera tale che questi non creino disturbo alla fauna, soprattutto nei periodi più delicati della nidificazione. Ecco, questo è il nostro impianto di fitodepurazione, di cui adesso vi dico molto velocemente. È un impianto che, come vi dicevo, appunto riceve delle acque che arrivano dal depuratore. Le acque vengono convogliate nella parte, questa è la parte, diciamo, la parte iniziale, da cui dopodiché partono 2 linee idrauliche che confluiscono per una vasca finale e da qui l'acqua, attraverso un certo percorso idraulico, viene mandata agli stagni. L'impianto era, quando è stato realizzato, era uno dei più grandi d'Europa e tra l'altro una tipologia assolutamente innovativa per trattare delle acque reflue. Quindi noi, e soprattutto non si trovano impianti di questa tipologia in aree protette, tantomeno che all'interno di un parco, quindi è assolutamente una peculiarità. Il nostro impianto di fitodepurazione è estremamente importante perché ha il compito quindi di affinare delle acque reflue, quindi di abbattere contaminanti di diversa natura, perché poi deve produrre delle acque di buona qualità che servono per l'alimentazione quindi dei nostri stagni. Ecco qua, queste sono alcune delle immagini degli stagni dove vengono poi immesse le acque dell'impianto di fitodepurazione, e queste sono appunto questo qua è Bella Rosa Minore e questo qua invece è il Perdalonga. Come vedete, quindi sono delle estensioni abbastanza importanti che vengono alimentate. L'impianto è un biotopo di importanza fondamentale, cioè è assolutamente stato colonizzato da fauna, tra l'altro molte delle specie che vivono nell'impianto sono delle specie estremamente rare e protette a livello comunitario, addirittura alcune a rischio di estinzione, come per esempio il pollo sultano. Quindi ha una valenza da un punto di vista conservazionistico estremamente importante, ma questa non è la sua unica diciamo importanza, perché le acque di questo impianto vanno ad alimentare quegli stagni che vi ho detto prima, ma in quegli stagni è presente un habitat comunitario prioritario. Cosa significa? Gli habitat prioritari sono quelli che la direttiva Habitat mi dice che sono particolarmente meritevoli di forme di tutela e di conservazione specifica, quindi sono quelli più a rischio, sono quelli più fragili, sono quelli che devono essere maggiormente tutelati a livello europeo, quindi non ha soltanto importanza locale, ma proprio un'importanza a livello europeo. Quindi noi abbiamo un impianto di fitodepurazione, questo impianto di fitodepurazione mi fornisce delle acque che vanno in habitat prioritari, quindi è chiaro che devo assolutamente essere certa che la qualità delle acque che io immetto deve essere altissima. E come faccio per capire questo? Sempre con le attività di monitoraggio. Attività di monitoraggio da che qui diciamo, entra il discorso della nostra collaborazione con l'Università di Cagliari e col professor Schintu nell'ambito infatti dell'utilizzo dei DGT e quindi del monitoraggio di tipo passivo. Infatti abbiamo effettuato una serie di campagne di monitoraggio con il professor Schintu diciamo nelle vasche dell'impianto. Qua si vede appunto alcuni dei punti fondamentali dell'impianto. La prima attività di monitoraggio risale addirittura al 2011 e dove eravamo andati a vedere i colleghi dell'università avevano appunto posizionato i campionatori passivi direttamente all'ingresso delle acque reflue che vengono dalle depuratori di Sarenas, quindi era un ambiente anche abbastanza estremamente difficile, una matrice molto difficile. Ecco, vedete, infatti queste sono delle immagini delle attività, come vedete appunto si era lavorato in condizioni abbastanza particolari, avevano stati utilizzati sia anche i DGT e poi gli SPMD. Un'altra attività sempre che è stata ripetuta nella stessa area è quella del 2019. Nel 2019 c'era anche Natalia, me lo ricordo bene, e siamo andati, oltre a Barbara e Alessandro e Marco, siamo andati a effettuare le attività di monitoraggio sempre nell'ecosistema filtro, però in questo caso abbiamo studiato invece più aree di campionamento, quindi ben tre punti di campionamento dislocati all'ingresso, diciamo, delle acque reflue, a metà del percorso idraulico e alla fine del percorso idraulico. Un aspetto interessante di effettuare attività di monitoraggio nelle aree protette è che molto spesso il territorio delle aree protette è estremamente controllato e videosorvegliato. Per esempio, noi abbiamo tutto un sistema di telecamere collegate che ci permettono di controllare la presenza oppure per esempio di elementi di disturbo o di pericolo. Quindi andare a fare un monitoraggio all'interno di un'area protetta come può essere il parco significa che comunque sta lavorando in condizioni di sicurezza, perché sicuramente i DGT non te li tocca nessuno, ecco, sempre che non te li tocchi la fauna, quello è un altro rischio. Ecco qua, qui sono alcuni soltanto dei momenti di monitoraggio. La preparazione l'abbiamo fatta qui, esatto, sempre quanto. Invece nel 2022 abbiamo affrontato un'altra problematica. Il parco, infatti, come vi dicevo prima, è un'area che è circondata completamente dal contesto urbano e anche per certi versi industriale, e quindi le problematiche di inquinamento chimico sono estremamente importanti. Adesso non è questo l'unico caso, purtroppo per noi, abbiamo altre zone con altre contaminazioni altrettanto importanti, però qui ve le faccio vedere, vi rappresento quello che è l'attività che è stata fatta nella vasca cosiddetta culatica, da cul-de-sac, era il nome della vasca in origine quando c'era attiva l'attività saliniera. Questa è una vasca dove in passato era presente un tiro a piattello, che è stata un'attività che è stata portata avanti per tantissimi anni e che ha determinato quindi un accumulo di residui dei piattelli e sia sul fondo della vasca sia intorno a tutto quanto le rive. Da tutta una serie di appunto dei monitoraggi che vi dicevo prima, avevamo individuato appunto la presenza, abbiamo fatto tutti i metalli pesanti, sia anche in carote fino a 50 cm di profondità, oltre non si poteva andare, e quindi abbiamo individuato una diffusa contaminazione da piombo in tutta la vasca, in tutte le acque della vasca. Contemporaneamente però le analisi invece sulla matrice acqua, le analisi tradizionali non mi indicavano la presenza di piombo. Contestualmente però, e qui riprendiamo il discorso della biodisponibilità che abbiamo fatto, di cui si è già parlato stamattina, avevo fatto fare le analisi anche su tutti quelle diciamo animaletti, sono dei piccoli crostacei di cui si nutrono per esempio i fenicotteri ma anche tanti altri uccelli, e lì invece le concentrazioni di piombo che avevamo trovato, mi ero interfacciata con alcuni docenti di università europee, perché gli studi sulla concentrazione del piombo sull'artemia salina non sono così numerosi, e quindi avevamo individuato che le concentrazioni di piombo in questi animaletti invece sono estremamente importanti, quelle del Molentargius, in confronto alle concentrazioni di piombo sulla stessa specie ritrovate in altre saline del Mediterraneo. Quindi noi abbiamo questa criticità di cui abbiamo bisogno di approfondimento. E questo infatti è l'immagine della vasca, e da un punto di vista diciamo degli habitat, perché noi naturalmente, ve l'ho detto, siamo una rete Natura 2000, per cui la nostra mission è quella, e qui si vedono tutti quanti questi poligoni colorati, sono tutti gli habitat comunitari che vi ho detto che sono stati segnalati in quest'area. Quindi come vedete abbiamo diversi habitat di interesse comunitario, di cui uno addirittura è un prioritario, quindi un'area fragilissima, un'area che merita la massima attenzione. Vedete qua in queste foto vi ho messo i pezzettini di piattelli che si trovano nel fondo della vasca, ma si trovano anche i piattelli interi, eccoli. Tra l'altro questo materiale questo specifico tipo di piattelli era costituito sì d'argilla, ma poi veniva utilizzato pece. Quindi oltre al piombo nei piattelli ci sono moltissimi idrocarburi policiclici. Quindi insomma abbiamo un stato ambientale abbastanza fragile. Vedete che condizioni sono certi tratti della riva, completamente pieni. E qui sono le attività di monitoraggio che abbiamo fatto appunto con i DGT e abbiamo sperimentato, quindi è stata sperimentato, l'università ha sperimentato anche la possibilità di utilizzare questo strumento in ambienti assolutamente limite, ecco, come quelli di una salina. Ecco qua giù si vede questi due cosi piccoli, sono, mi sembra Barbara e Alessandro che fossero in acqua, appunto per riposizionare i DGT. Eccoli qua, e qui sono invece le inverse immagini dei momenti, con il rilevamento, come si diceva prima, importantissimo dei parametri chimico-fisici, e i fenicotteri che popolano quella vasca. Il giorno non ce n'erano, però comunque è usuale vederli, ecco. Infine, quindi vi riassumo brevemente perché è importante l'utilizzo del monitoraggio passivo, quali sono tutti i vantaggi che dà il monitoraggio passivo all'interno di un'area protetta, quindi un'area fragile che merita particolare attenzione. Innanzitutto mi permettono di quantificare contaminanti presenti in concentrazioni bassissime. Come vi ho detto, tramite i GGT si è rilevata la presenza del piombo, mentre con le analisi tradizionali ripetute anche per 5 anni, non abbiamo mai trovato assolutamente traccia di metallo nelle acque. Quindi questo è estremamente importante. Mi permette di avere delle misure integrate nel tempo e mi permette anche di capire quant'è la biodisponibilità dei contaminanti, e quindi per me maggiore biodisponibilità di contaminanti significa che mi si possono accumulare nelle specie che vi ho detto, fenicotteri, polisultani, eccetera. Per esempio in diverse parti d'Europa ci sono stati dei fenomeni di saturnismo per quanto riguarda i fenicotteri che si erano alimentati diciamo di un pabulum dove c'era molti metalli pesanti, molto piombo. Da noi questo non è capitato per adesso. Poi mi permettono, molto utile, mi permette poi di verificare come cambia il livello di inquinanti lungo un percorso idraulico. Quando devo andare a gestire praticamente un impianto di filtrodepurazione, io devo capire come sta funzionando un impianto nella tutta la sua estensione di 37 ettari. Non mi interessa sapere soltanto l'inizio e la fine, io devo capire se ci sono dei problemi nelle vasche lungo il percorso idraulico. Quindi i DGT mi permettono di capire come varia nello spazio anche tutta la concentrazione dell'inquinante. Ancora poi estremamente importante per un'area protetta è questo punto. Questo forse è il più importante, cioè uno dei più importanti, perché l'utilizzo dei campionatori passivi è un'operazione facile, è un'operazione che richiede poco tempo, che può essere fatta da pochi operatori, 2 persone, 3 persone, piuttosto che intere squadre che devono prendere ettolitri di litri di acqua e chili di sedimenti, per intenderci. E infine vi voglio raccontare quelli che sono, diciamo, i miei sogni, cioè le mie prospettive future, perché al momento il parco ha avuto un importante finanziamento dalla Regione Autonoma della Sardegna per l'area dell'acquatica, perché ci si è resi conto dell'importanza della zona e ci si è resi conto della necessità di provvedere ad interventi di bonifica, come vi ho detto prima. Quindi adesso noi siamo obbligati per la normativa vigente a portare via tutti i piattelli e fare quella che viene chiamata una messa in sicurezza dell'area, però successivamente dovremo andare a fare un piano di caratterizzazione, quindi capire se nonostante questi interventi permangono delle problematiche ambientali, quindi inquinamento da metalli o quant'altro all'interno nell'area. Quindi qui ovviamente i DGT ci potranno dare un uso, cioè speriamo di poterli usare assolutamente, perché sarebbe estremamente importante, visto che comunque mi permettono anche di capire, di rilevare concentrazioni estremamente basse, e poi naturalmente anche per l'ecosistema filtro, perché anche lì abbiamo necessità di fare delle operazioni di manutenzione, abbiamo avuto un grosso finanziamento e i DGT ci potranno dire se stiamo lavorando bene nelle operazioni di manutenzione, nella progettualità, nell'applicazione della progettualità o meno, se dobbiamo raddrizzare il tiro. E con questo avrei finito, vi ringrazio.
Grazie Laura. Volevo ricordare una questione che almeno soprattutto per Miguel e Isabel, perché noi abbiamo preso per MONITOOL Extension, questa era una delle nostre stazioni, e la salinità era estremamente alta. Quindi l'analisi di questi campioni che abbiamo preso ci ha messo qualche difficoltà analitica, perché soprattutto per quanto riguardava il flusso la velocità del flusso dell'acqua. Però abbiamo visto che poi i risultati sono stati ugualmente attendibili. Non so se Miguel voleva dire qualcosa. Did you understand, Miguel? There was the problem of salinity in these samples. Very high salinity of the water in the, anyway, we
so we can do it in two ways. We can dilute the sample first and then pass it through the CFAST and then analyze it just to regulate the metal concentration. Or if the salts are not so high as that, could be higher, could be, I think it allows 40 degrees, Pedro, 40 ppts of salinity. Yeah, if it is around 40 ppts, we can put it directly in the CFAST, but that's not an issue in this type of.
Okay.
And the results were reliable, very comparable in between.
It was a sampling station with very high concentration of lead.
And that was surprising because lead tends to form an oxide part on the outside that do not promote the corrosion in some places. But in this case, maybe the characteristics were different and you have lead in the water.
Okay, thank you. So I invite to speak Gary Fons from. Just a second. Abbiamo avuto un cambiamento nell'agenda perché abbiamo spostato l'intervento del professor Regoli e di David Pellegrini dopo il coffee break. Quindi abbiamo anticipato l'intervento del professor Gary Fons. Non l'avevo detto.
Thank you, Marco. So not that many of you play cricket here, but in a cricket analogy, I feel as though I've been pushed up the batting order a little bit. So thank you very much for the invite and also all the interesting talks that we've had so far. So what I'm going to talk about is some of the things that we've already seen. So a little bit of background history in terms of passive sampling so far, but also have a think about what's going to happen in the future. So where are we going to take passive sampling in the future? So the title is 30 years of passive sampling, what's next? You'll get an idea of why it's about 30 years or so. So I'm going to give a little bit of background history. We've already seen stuff about different passive sampling devices. We've already seen things about examples of DGT use, but I'll just show some of the things that I've done. It'll probably allude back to some of the stuff that Hal showed a little bit earlier. But then we'll think in terms of the passive sampler that I've been using the last 15 years or so, which is ChemCatcher. But I also want to think in terms of the future. So what can we actually do with passive sampling in the future? And one of the things, and we'll get to it, but one of the things that I think we need to do is take on board all of the key analytical chemistry advancements that we have so far. And I'll show you what I mean by that when we get to the last few slides. So a little bit about background about passive sampling. So it's been around a lot longer than people thought. Anything that can uptake something. So even back in the 1920s, people used plant uptake or lichen uptake or things onto there in terms of passive sampling. It really started in the 70s in terms of air monitoring, but more as we started in the 90s, as Hal alluded to earlier in her talk, in terms of in the 1990s, we had DET, DGT, and then a whole plethora of different passive samplers with lots of different acronyms, and then also ChemCatcher. So I said about 30, it's actually a little bit less than 30. So I started working on passive samplers back on the 1st of March, 1995. So that's just over 28 years. And that's how long I've known Hal since I started work at Lancaster on working on DET and DGT. So initially it was on sediments. Then I did some work in the US on DGT in the water column. Then I moved to the University of Portsmouth, where we've been working mainly on DGT to start with, now lots of ChemCatcher. So initially, so my kind of background is more analytical chemistry. So I've always looked at lots of different analytical techniques and how can we push the advancements of those coupled to what can we actually do with passive sampling. So I think the real key is those two need to go kind of hand in hand. We saw a kind of a similar one to this that both Hal presented and Jean-Louis presented in terms of different types of passive samplers and what can we actually monitor. So a whole different range of passive samplers, a whole different range of contaminants in terms of metals, nutrients, PAHs, pesticides, pharmaceuticals. What other ones have we done? In terms of radionuclides, organometallics, all different types of passive samplers, all different types of contaminants that we've used across a number of different types of matrices. So surface water, groundwater, sediments, etc. I'll show you some a little bit later, but this is one we'll have a look at a little bit later in terms of the ChemCatcher and obviously DGT and POSIS and lots of other different types of passive samplers. So one of the things that we've been looking at in terms of MONITOOL is, can we get this into some kind of regulatory context? So EQSs, can it be used in regulatory monitoring? So one of the advancements has been more on the non-polar pollutants. So look, using silicon rubber sheets, PDMS sheets. So these are starting to potentially make their way more into that Water Framework Directive routine compliance monitoring. It's good to see that DGT, maybe for metals, is starting to get in there. And what we really need, as well as all the analytical techniques, is more usage of passive samplers, or how we can integrate passive samplers into routine regulatory work. And we don't just rely on that one-off spot sample that's going to define everything that we do. We need to somehow convince people to embrace passive samplers in terms of regulatory and compliance monitoring. And this is a paper that my PhD student wrote a few years ago in terms of a review of all things non-polar, really. So started work on sediments. Hal has alluded to some of that sediment work that we did before. So Bill's name appears on there quite a few times in terms of things that we were doing really when we started to look at that process-driven stuff rather than all of the monitoring, a bit more monitoring work that we do now. Oh, look, you are over there as well. So we've then got, we then have a number of different kind of papers or different applications. So things where we can then start to look at those processes, but then maybe think, how can we utilize those more in a bit of monitoring? So I had a PhD student that worked on radionuclides, but we thought we'd turn that into thinking more in terms of how do we sort of initiate this into the monitoring side? How can we do long-term monitoring over a long period of time? We've spoken about the cost in terms of, well, we have to go and deploy it, then we have to go and retrieve it. But what happens if we put a new set of passive samplers in when we did the retrieval? So we've got this continual time series over a long period of time, maybe up to a annual cycle of trying to use that for long-term monitoring. Now, Hal mentioned this before. This is some work that we did in the US, thinking in terms of this speciation, but bioavailability and toxicity. So MONITOOL has all been about using that kind of that sort of standard DGT, but is there some way that we can take a DGT, modify it? We've tried it before. We've done restricted gels. We've done various other things in terms of changing the type of resin, changing the thickness, putting different barriers in the way. But I just wonder whether it was kind of time to revisit that, to think more in terms of bioavailability and the kinetic side that Hal was talking about earlier. And from the work that was done in MONITOOL in terms of all of the looking at the kind of the free metal ion in terms of the electrochemistry work, is there some way that we could start to think in terms of maybe a DGT probe that might give us some more of that direct speciation work? We tried it for a year or so. It was very complicated to try and to link everything together. But maybe, as Hal alluded to, that there's someone cleverer out there than us to come along and solve all those bioavailability and toxicity issues. We used a molecular weight cutoff. I'm sure there's more elegant and eloquent things that we could do in the future. So just as to bring on to the passive sampler that I've been using, which is a thing called ChemCatcher. We can use this for a number of different receiving phases. There's no diffusive gel. We just have a protective membrane, or the diffusing membrane, and then we have this solid phase extraction disc, which is our kind of our uptake phase. Number of different types of receiving phases in terms of a chelating one or anion, cation. We've started to use this hydrophobic lipophilic balance, this thing called HLB, which is very good for our polar organic contaminants, which is what I'm going to talk about next. So when we can't think in terms of polar and non-polar, in terms of things that want to be in water or not in water, we have to think in terms of the uptake and what the chemical kind of physical properties or the chemical properties that we're looking at. So we need to think in terms of this coefficient, this log KOW. So we're really looking at things that are falling within this section here. This might get a little bit complicated down here. And then as we get high log KOWs and we move into more non-polar, then it might be time to think about a different type of passive sampler. So maybe the silicon rubber, or maybe we can change the phase. So in terms of using the ChemCatcher, we want to think of it, and have been using it in terms of a lot of contaminants of emerging concern, or some non-regulated pollutants. So lots of pesticides, lots of pharmaceuticals or hormones or human personal care products, lots of veterinary medicines. But also, which was people have started to look at now, and it's become a very big hot topic, is thinking in terms of these PFAS chemicals, of which there's thousands and thousands of different PFAS chemicals that we can look at. We also want to start thinking now in terms of metabolites and transformation products, particularly coming from all of those organic contaminants. So things that might change in the environment, things that might change once they've been through wastewater treatment plants. Some of these appear on the Water Framework Directive watch list, but I think that for organic chemistry, we might be missing, if we're not thinking about all of these different metabolites and transformation products, we're kind of missing out on that the big picture or understanding of what is in the environment. So at Portsmouth, what have we been doing, or what do we currently do? So we've been using the ChemCatcher passive sampler with the HLB disc. We've used a liquid chromatography mass spec. So we've done like a triple quad or time of flight. And one of the things that we've done to start with was looking at targeted analysis. So thinking of kind of trying to calibrate to be able to analyze particular organic contaminants. So certain things like acidic herbicides like 2,4-D, MCPA, things that get into the environment from weed management. We looked at this thing called metaldehyde, where we had a big issue in the UK, which was a slug pellet, and it got into the water and it couldn't be extracted from the drinking water. But what we've started to do now is look at all this. So using either a QTOF or Orbitrap, we started to do non-target screening and suspect screening. So extending out the range of contaminants that we can look at. So we're starting to get thousands and thousands of different contaminants from our chromatogram. And then they're not all calibrated, so we can't say what the concentrations are, but we can then start to think in terms of kind of loadings, where all these pesticides are coming from. And we can start to integrate that more into some kind of multivariate statistics and catchment management, thinking about risk assessments, where are these pesticides coming from, what's happening to them in the environment, where are they going, are they ending up in the treatment works, which I'll show you in the next one. So that's the kind of thing that we're doing, thinking in terms more now of utilizing that sort of cutting edge analytical chemistry in terms of advancements of LCMS, but also utilizing the passive sampler as a tool. So can we sequester more contaminants? Can we get a bigger picture of how many more contaminants are there? Can we start to use this for catchment management? So the main things that we look at: pesticides, pharmaceuticals, personal care products. As I said, we need to try and start to expand this out. One of the things that we've done, certainly in terms of some catchment work, is then look to see what happens as the pesticide loadings in the water that's extracted, that goes through the drinking water, so it eventually comes out of your tap. What happens to the pesticides there? So we placed ChemCatcher devices at various points throughout the water treatment system, which is this paper here. This was work done with Southern Water. And then we did some multivariate statistics. We did some suspect screening. So we're getting we're trying to figure out what's there, what the efficacy is in terms of how the pesticides are removed as we go through that treatment works. Some of the other projects we've been working on have been in lots of UK rivers, so lots of chalk streams in the south of England. We've done quite a bit of international work in terms of working in South Africa, Thailand. We've been doing some work in Israel for the Ministry of Agriculture, and working with a number of different NGOs. in the UK. And later on today, John's going to talk about ChemCatcher itself, because that's now you can now buy ChemCatcher through TE Labs. So that's going to come up a little bit later. So now for a slightly more kind of philosophical take on what are we going to do with passive samplers in the future? So what do we already know, or what can we do? So we know that passive samplers have been used to analyze for a whole host of different contaminants in a whole host of different environments, and for some regulatory work, investigative work, we're looking at EQSs, etc. So, oh, that's my timer. So what's missing and some of the challenges ahead? So I think some of the challenges ahead is trying to get an understanding of like I would call it a full chemical profile. So what is actually in the water that we're looking at? Can we measure everything in the water? And then we might need to be a little bit reflective and take a step back and think, why are we actually using passive samplers? What is it that we're using passive samplers for? Why can we not just take a spot sample? What's the key reason that we're using passive samplers? So one of the things that we're going to be doing at Portsmouth and also at Southampton, where we've got our new instrument, is trying to think in terms of, let's push the advances of analytical chemistry, but link those in to passive sampling. So it's a big hyphenated fancy piece of kit, which has got, so it's a 2D liquid chromatography, ion mobility, all singing, all dancing. The idea is that we should be able to expand out the number and the different types of chemicals that we can look at. Can we find previously undetected transformation products and metabolites? Can we work in slightly more complex and complicated matrices? So some of the things that we want to do is think in terms of maybe trying different novel receiving phases. Can we do that on the 2D side? Can we do that in terms of changing the different types of resins or receiving phases, things that Hal's alluded to? But then also taking this a step further and thinking in terms of, well, if we can start to get a fingerprint of our water, particularly on the kind of the organic side, can we then start to use it to answer some kind of ecosystem questions? So in the UK, there's big pressure in terms of sewage dumping, impacts on our waterways, certainly impacts on chalk streams, some of the rivers in the south of England. Can we start to mix all of this information together of passive samplers, of new hyphenated, all singing, all dancing techniques, and start to piece together some kind of solution, or at least give some answers into why we're seeing this degradation of some of our ecosystems in the south of England, in these chalk streams and our little macro invertebrates and fly life. So what can we do in the future? So I said maybe some new contaminants and compounds. People have already started doing this in terms of looking for PFAS, maybe explosives, pushing the boundaries with the analytical to look for more, to be able to cover everything that we want to look at. Certainly in thinking in terms of antimicrobial resistance, getting that full chemical profile, coming back and revisiting sediments, of which I saw Hal mentioned earlier. So thinking about organic contaminants in sediments as well. And then what should we continue to do? So take the strengths of those passive sampling along with the analytical techniques and think in terms of why we're using them. Time-weighted average concentrations and EQSs are ideal. Can we then also use them to obtain this high resolution data in areas which are very difficult to continually go back to, or it's more expensive, or it's difficult to access. We've done some work in Israel looking at kind of the first storms and the first flush, and it'd been impossible to get there and take samples every day. Whereas if we can put a passive sampler in, maybe just before the storm, it captures all that water as it flows through, saves time, saves money. Come back and think in terms of why we're using them. What's the key questions that we want to ask? Are we trying to lower detection limits? Are we trying to break away from matrix effects? So I often get asked questions in terms of, can we use passive samplers to do X, Y, and Z? And I was like, but what is it that you want to do? Do you really need a passive sampler? Or do you just need the fancy hyphenated technique? So I think the two of them can go hand in hand. We need to think in terms of what is it that, why do we need to use them? What do we want to use them for? But certainly the next key step, and I've been to so many meetings and workshops where it's always the next key step is to think in terms of how do we get passive sampling, be it whatever name or brand it is, how do we get that into the regulatory context? How do we get the environmental regulator to start using passive sampling? And there we go. Thank you very much.
Thank you, Gary, for the philosophical approach. Now I think it's time to have an online speaker. Is Brendan from Ireland. I don't know if he's ready.
Good morning. Good morning. I'm here. Just trying to find my presentation.
Hi, Brendan.
Good morning. Pity, sorry I cannot be there with you today. Unfortunately, it wasn't feasible, but I've been very interested in all of the discussions so far. And I think what I aim to do today is maybe to take a little bit of an overview as well on the regulatory side. I come from a background where I'm involved in marine monitoring, maybe not quite as long as Gary. 1996, I think I started in marine monitoring. I worked for the Irish Marine Institute, and I've been part of this project as an associate partner. So today, what I want to just maybe introduce a little bit about how do we take all this nice work and what are we going to do with it in the future? I'm going to give a little bit of a brief history, similar to what Gary has done. A little bit of it's a road well traveled as far as I'm concerned. There's so much information about passive sampling out there. And how are we going to take that information and what are we going to do and how are we going to be able to move it towards compliance monitoring? So then a little bit about the future and initiative that we're looking at under the Norman Network. I'll introduce that on how we might move things along in terms of passive sampling. So the history lesson, 2002. This is an example of an output from 2002 where there was an initiative across the OSPAR network, which is the monitoring of the wider Northeast Atlantic. So a number of countries participated in a survey for PDMS, silicone passive samplers. And it was the first one where there really was a sort of a wide, expansive scale screening initiative undertaken. And you can see there that even in 2002, for PCB 153, we were able to get down to picogram per liters. So that actually was a huge advance. And at that stage, we were able to develop guidance on the how to complete sampling, how to develop partition coefficients, how to develop the protocols and reporting. And these are all key elements of what is needed in order to be able to move passive sampling on. Other initiatives kind of quickly followed. There was a STAMPS initiative, which was a standardized aquatic monitoring campaign. There was the SWIFT WFD, so very much focused on the WFD. And under that program, the SWIFT WFD, a guidance document came out back in 2009, which brought about where passive sampling could even fit as a complementary method within the Water Framework Directive. Have things moved on in terms of its application for WFD or compliance monitoring? I don't really think so. Many other examples, looking at Nordic countries, some nice work in France. Jean-Louis has detailed examples in France, and I'll come back to work that is ongoing in France at the moment. There's the Solutions Project, and then there's things like the AquaGaps Project. The AquaGaps Project was a global initiative, so it's not just on a local scale, this is on a global scale. So this is looking at developing a network of passive samplers around the world, which is looking to try and get a global picture for the application of passive samplers and to look at the global distribution of pollutants. Some of the outputs from that, they're very, very comprehensive in terms of relating one types of device to another, in terms of the range of compounds that you can get. And people are, the AquaGaps project are always looking for new people to be involved at both a riverine and a marine scale. So it's a sort of an initiative that has an open date on it. Then in 2016, I think Case is on the call today. So I'm going to use his paper as a sort of a kind of one of the seminal moments in passive sampling history, I suppose, because at that stage, a paper was published with a wide range of authors from all over Europe, looking at passive sampling and regulatory chemical monitoring. And this is specifically for non-polar, but can equally be applied to any of the techniques that we have in front of us today that Gary has very nicely outlined. Key conclusions from that piece of work were that passive sampling works, but there are lots of gaps. And those gaps include insufficient quality control, accuracy, laboratory performance studies, sources and variability of the results, inaccuracies in various constants, use of PRCs to be able to do your water sampling rates. These have all been major sources of concern, and that more research is needed to assess how these passive samplers can be best linked to concentrations and higher levels of the environment. So these were key sort of research gaps that were identified back in 2016. Things have moved on, and with the help of projects like MONITOOL, they've really, I think, addressed so many of the questions that I've just sort of posed, or the case and the group posed back in 2016, in terms of developing our understanding of around accuracy, around the relationships, around how to operate these devices in water, in the aquatic environment. Other ones, such as work in different hydrogel devices, have identified calibration studies, how to calibrate them, constants, all the important aspects that are required. And recently as well, in late 22, a number of papers have now started to look at, in the case of the non-polar compounds, where do passive samplers sit in terms of being able to describe our environment. And in this case, with a Nordic paper, they've shown that biomagnification of certain compounds is not actually visible, or doesn't seem to be visible. So up to this stage, things like HCB were always assumed to have a level of biomagnification, and other similar compounds to biomagnify. And use of passive sampling has sort of, I suppose, debunked some myths, but it has supported others. And this has been really crucial in being able to have a level of confidence in the measurements that passive sampling give to us. And similarly, one of the last questions that was identified by Case and the group back in 2016 was around having a relationship to higher trophic level organisms. Foppus Medes, I would call him one of the fathers of passive sampling, has done his whole career has been essentially around developing passive sampling in a monitoring context. And what this paper is key to a lot of what is really valid in particularly in Water Framework Directive context, where that passive samplers are kind of seen as being the equivalent of higher trophic level organisms. And this is a sort of one of the key moments where people have been able to say the passive samplers are actually equivalent of a lot of the higher trophic level organisms that exist in the aquatic environment. So we have all this information, and it's very clear today from the nice examples from Jean-Louis, from Laura, from Natalia, and from Gary, that information exists all over the world. But I think Blonid put it very nicely this morning, that by working as individuals, but also that there's the power in the collective, and the collective such as MONITOOL to kind of pull together this information. And I think that's one of the key gaps that is missing. And it is something that the Norman Network, you may or may not be familiar with the Norman Network, but I've left a link there to their website, and Fiona Regan, who is also on the call, would be a member of the Norman Network and would be instrumental in some of the activities that we undertake within the network. But there's one particular activity is under passive sampling. And the aim of that is to collate the key examples of passive sampling around the world. So such as the examples of MONITOOL, such as the examples of ChemCatcher. And we're trying to pull this information together in one location. And that location, we hope, will be on the Norman website. And we want to pull together information on sampling and field considerations, how to do things, the templates, sample handling, LODs, LOQs, modeling, how to go about the modeling, identifying the research gaps, and to increase the visibility of passive sampling, and have people such as policy people and environmental managers have one location to go to where they can see case studies, where they can see people having applied these techniques in a sort of in a real sense, and that they can then have a little bit more confidence that there's a community behind this. While in the absence of maybe a compliance monitoring agenda, I suppose, for passive sampling, to be confident that there maybe is still a role for passive sampling to support the work they're doing. So it has moved on a little bit. Jean-Louis actually showed this picture earlier on, so I stole it from one of the pieces of work in France. Passive sampling has been transposed into a piece of law in France. So it will be a technique that will be usable in order to support monitoring into the future. And I don't have the details of that, but perhaps some of the French audience, if people need information, we'll be able to provide it. But it shows that the people are taking this seriously, and that from that when it is moved into a piece of legislation, all of the guidance documents and all of the support that is needed in the same way as spot sampling can be produced and can be used as evidence to support that passive sampling can offer on occasion similar levels of protection than the existing sampling modes such as biota or water. And just a very, very quick example of, this is just one example of where passive sampling can sit within a compliance setting. If you're to take normal water sampling or biota sampling as your tier 2, where you complete your sampling program on shellfish, on fish, and on water, then passive sampling could go in a previous stage before that, where if you were to exceed a threshold as set through your passive sampling scheme, or that you were to see a presence or absence of a compound, or indeed that you were to see upwards trends at a particular location, Then if you exceed these trigger points, these points being similar to those that were identified earlier by Isabel when she was showing numbers around the EQSs, that these detection or non-detection can point you in a direction as to where your sampling program could go. If you fail these trigger points, then obviously you may need to go into further water and biota testing. And then this helps to support you in your refinement of your understanding of the extent of the problem and lead you on to your programs of measures. So very quickly, in summary, contaminants and chemical threats to our aquatic environment are ever increasing. We're into the hundreds of thousands of potential compounds. The compliance limits and thresholds, and especially on spot sampling, are decreasing. And these are becoming ever more difficult for us to achieve analytically. And the relevance of those in water is being questioned much more. The research in passive sampling, I feel, is very mature, greater than 30 years, and it continues to evolve. And it's now very much applied, and the examples shown by Gary and others show that the research is very applicable in the monitoring context. We have information now on QC, on performance studies are available, reference materials, templates for reporting, user guides, reporting schemes, and everything is now sort of generally available to the user. And these are really core to our confidence in the technique going into the future. Passive sampling applications are available in every country. Again, and it's the individual countries, while working on things at a national level, I think it can prove that maybe intimidating to move your monitoring onto a wider footing. So this is where the whole initiatives such as MONITOOL and where things like through the Norman network are key to moving the community on as such and doing things on a community basis. Screening, non-target screening is now possible. This allows us to be a bit more precautionary in our approach. So not just monitoring compounds that are listed on various directives, but to be able to expand that out into non-target, also to identify potential risks to your environment. You can link it very much nicely now to ecology and to PNEX. And you can then start to develop prioritization and other listings for your own country, which can lead you to measures. So again, just to very quickly summarize, I think the collective work and the initiatives such as MONITOOL are really, really key to this, and gathering together now all of the information that exists out there, I think is fundamental to where this goes in the future. And even after 30 years, I think all we can still say is the passive sampling still has very high potential as a support to monitoring, but quite a way to go yet, but I think progress is really being made. Thank you very much, and that is all from me today.
Thank you, Brendan. I hope you can join us for the final discussion. And now we have the coffee break. So we have a coffee break up to 11:30. Okay, I think we are missing some. Allora, adesso dovremmo collegarci con il professor Regoli e il dottor Pellegrini che fanno un intervento online, non so dove siano fisicamente, perché credo che siano anche in viaggio, e quindi vediamo se riusciamo a recuperarli. Ah, ci sono già. Ciao Francesco, ciao David.
Marco, buongiorno.
Ecco. Allora, noi abbiamo chiesto ai colleghi di parlarci di quelle che potrebbero essere i possibili sviluppi nell'utilizzo dei DGT nel monitoraggio. Loro si occupano soprattutto di weight assessment, quindi e soprattutto anche David Pellegrini si occupa di ecotossicologia, è uno l'ISPRA di Livorno è uno dei leader in Italia per l'ecotossicologia. Quindi noi collaboriamo da molto tempo con loro, abbiamo fatto e stiamo facendo ancora dei lavori che prevedono l'utilizzo di campionatori passivi nel porto di Livorno, però anche con Francesco Regola abbiamo lavorato in diversi ambiti. Quindi chiederei a loro di fare questo intervento, di spiegarci un po' quali possono essere gli utilizzi del campionamento passivo nel monitoraggio ambientale. Non so come sono organizzati. Ah, ok.
Marco, mi dai conferma se vedete le slide?
Vai.
Well, so I will give my first part of the talk in English, and then I will give the floor to Davide Pellegrini. And first of all, of course, I'd like to thank for the opportunity to present the weight of evidence approach in ecological risk assessment. In fact, when defining the quality of the marine environment, it is widely recognized the importance of multidisciplinary approaches. And in this respect, I'd say that the integration of several typologies of investigations, the so-called lines of evidence, is important to obtain the greatest number of useful elements to describe the complexity of an ecosystem. However, despite there is a general consensus on multidisciplinary approaches, there are also some critical issues in risk assessment when moving from a conceptual level to the practical activities. And some of these critical issues are the interpretation and significance of complex data sets of heterogeneous results, qualitative and quantitative evaluations of risk with development of indices and scales, how to integrate the different typologies of data, and last but not least, the synthetic risk characterization and communication to non-expert political decisors. In this complex scenario, we have recently developed a weight of evidence model which is routinely applied to chemical pollutants based on weighted criteria, logical flowcharts, and mathematical algorithms that integrate data from different lines of evidence like chemistry, bioavailability, sublethal effects with biomarkers, laboratory bioassays, and benthic communities. And we wish that the additional lines of evidence could be DGT. Synthetic hazard indices are elaborated for each typology of data before their overall integration in a risk index. Now, due to the time, I won't give you specific details on the mathematical calculations, but I will try to give you a general overview on the concepts that are included in such calculations. So also describing some of the outputs of a specific software which combine the scientific soundness of the approach with the need to provide an easy interface for non-expert stakeholders. And starting with the elaboration procedure of chemical results in water and sediments, the key aspect is to abandon the pass-to-fail approach, where a single chemical parameters, even slightly above or below its relative threshold, even let's say 1% would determine the shift of a chemical class. Weighted criteria have been elaborated, which consider how many parameters exceed their thresholds, the magnitude of such exceedings, and the typology of exceeding contaminants, giving more relevance to priority or dangerous chemicals. And based on these features, the cumulative hazard quotient is then assigned to one of 6 classes of hazard. The model output, as you can see, give the quantitative hazard value, the qualitative class of hazard from absent to severe, but also important information such as the maximum percentage contribution given to the hazard value by a single parameter, so the number of exceeding analyzed, or any other information that we might consider important to be shown in a report. The module is flexible in terms of parameters that can be included or updated. And in terms of normative guidelines that can be national, international, or even local, since the elaboration procedure is not dependent from the chosen reference. Bioavailability, as we also heard in the previous talk, is fundamental because it allows to define if chemicals are transferred to the biota, which should represent a greater risk. And the main step, again, for the calculation of the hazard index are to calculate for each parameter the increase of concentration compared to control conditions, corrected once again for the weight or typology of chemicals and the statistical significance of the difference. Each parameter is then assigned to one of 5 classes of Fs, and again, the cumulative hazard quotients is summarized and shown by the software in terms of percentage distribution of parameters in various classes of Fs. Biological responses can be measured, we know, at different levels of organization, from molecular cellular responses up to benthic communities. At the molecular cellular level, the model contains a large selection of biomarkers, again, easy to be updated, and each biomarker, according to the species and the tissue, has a weight based on the toxicological relevance of the endpoint, and has also thresholds indicating those changes which are considered of biological significance. Again, very briefly, the specific hazard index for molecular responses is assigned to one of 5 classes of hazard according to the number of changed biomarkers, their toxicological relevance, and the magnitude of such variations compared to the threshold. The approach with the ecotoxicological bioassays is based on a large selection of species, biological endpoints, and experimental conditions. Again, the important aspect is that in the evaluation is not anymore the worst results to be considered for assigning the ecotoxicological classification, but the whole battery can be evaluated since, again, each bioassay has a specific weight depending on the biological endpoint and the threshold which define the sensitivity of the species, also according to the experimental condition. The software provides the evaluation summarized for the battery, but also all the indications related to each specific bioassays which was included in the battery. Benthic communities we know are widely recognized for their ecological value. And this is the reason why since several years, many elaboration procedures have been developed by scientific community. In this respect, we did not develop any new index or mathematical elaboration for benthic communities, but we just prepared or adapted the informatic tool in a way that from the list of observed species and the number of specimens, we can elaborate all the already available community descriptors or indices of taxonomic diversity and ecological indicators, then allowing to choose according to the investigated area, which is the more appropriate descriptor to be selected in the weight of evidence evaluation. And the core of the weight of evidence approach is the final elaboration and integration of different typologies of data. After normalization to a common scale, the hazard quotients from different lines of evidence are integrated, giving them a different weight according to their ecological relevance. Just to make an example, bioavailability has a greater weight compared to the presence of chemicals in sediments. Acute effects at the organism level have a higher weight compared to molecular responses, but lower compared to benthic communities. And again, after this normalization and integration, the cumulative weight of evidence risk can be assigned to one of 5 classes of risk, which make the interpretation easier for a non-expert stakeholders. Just to make an example, in a recent study on offshore platform, the weight of evidence model allowed to synthesize almost 7,000 data obtained from different typologies of investigations like chemicals in sediments, bioavailability, biomarkers, bioassays, and benthic communities, which beside the great added value in terms of scientific term, is also fundamental in making the comparison between different structures or between different periods. The model is very flexible. This is why we hope to include the DGT lines of evidence. Just to make an example, in a version intended for inland and freshwater environments, 9 lines of evidence have been integrated, incorporating numerous other lines of evidence required at the regulatory level. But the plasticity of the approach has been highlighted also in a recent study in Finland, where in addition to the typical lines of evidence like chemistry, ecotoxicology, and so on, the model was adapted to evaluate also the levels of eutrophication and of dissolved oxygen, which are of great importance in the Baltic Sea. Now I have concluded the first part of my presentation, and I leave the floor to David Pellegrini for the second part. Thank you very much for your attention.
Grazie Francesco.
Grazie Francesco. Allora intervengo io, Marco, va bene? Mi sentite?
Sì, sì.
Ok. Ecco, mi date un cenno se vedete la presentazione?
Va bene.
Ok. Allora, intanto anch'io ringrazio Marco per ovviamente questo invito. È da anni che collaboriamo e che cerchiamo appunto di trasferire questa, diciamo, anche metodologia degli accumulatori passivi nell'ambito normativo, tant'è che abbiamo inserito come ISPRA, quindi come istituto di supporto al Ministero dell'Ambiente, diciamo, questo approccio nei monitoraggi, ad esempio, della gestione dei sedimenti che vengono dragati nei porti. Per cui questo è stato uno dei primi passaggi dove questa metodologia dei DGT compare, degli accumulatori in generale passivi, compare anche a livello normativo nella regolamentazione italiana. Proprio a proposito di acque portuali, diciamo che, scusate un attimo, sembrava ci fosse, ecco sì, proprio a livello di acque portuali abbiamo collaborato insieme in un progetto appunto del marittimo, Geremia, ecco, dove abbiamo cercato di definire appunto un indice integrato proprio per la qualità delle acque portuali. E quindi, ecco, ricordo brevemente che le acque portuali sono considerate più una fonte di pressione e quindi sono escluse dalla classificazione dei corpi idrici costieri, secondo proprio le indicazioni della direttiva quadro. Direttiva che in Italia è stata recepita con un decreto legislativo, diciamo, ovviamente specifico. Le metodologie, i criteri che vengono proposti per, come dire, la definizione appunto della qualità delle acque costiere è un indice non esaustivo, in quanto è riferito solo alla matrice acquosa e quindi non considera altri comparti come il comparto dei sedimenti e il biota, e peraltro della matrice acquosa considera solo alcuni parametri come l'ossigeno disciolto, i nutrienti e la clorofilla. Quindi capite bene che, come dire, è abbastanza riduttivo come approccio. Per cui, ecco, diciamo, ci sono una serie di considerazioni alla base del progetto che mi piace qui ricordare. Quindi la prima è quella che abbiamo appena detto, che i porti non rientrano nella classificazione dei corpi idrici, ma non per questo, ecco, possono essere considerati solamente una fonte di pressione. È importante avere dei criteri per definire comunque una qualità, anche in modo quantitativo, per diciamo, pesare in qualche modo anche quello che è il loro possibile impatto, eventualmente sugli ambienti circostanti. Per i porti vi è comunque, ecco, la ragionevole impossibilità di raggiungere comunque un'elevata qualità ambientale secondo appunto i criteri utilizzati per i corpi idrici. Non a caso, no, se seguissimo il criterio, diciamo, della clorofilla o di altri, immaginate nei porti cosa potrebbe accadere. E quindi è sicuramente un ambiente complesso, quello portuale, che necessita di una serie di dati che devono essere integrati. E come diceva Francesco, noi abbiamo utilizzato quindi il modello del weight of evidence proprio per cercare di dare una rappresentazione qualitativa di questi ambienti il più possibile, diciamo, fedele, attraverso indagini fisico-chimiche, biologiche ed ecotossicologiche, sia dei fondali, quindi dei sedimenti, che della colonna d'acqua. Ovviamente da tutto questo poi ne conseguiranno, ecco, dei programmi di monitoraggio mirati a questi ambienti particolari che rappresentano spesso anche, come dire, ambienti in cui confliggono, diciamo, interessi diversi come quello della portualità o quello anche della molluschicoltura, almeno in Italia. Ecco, spesso ci troviamo di fronte a queste situazioni e quindi è importante avere un indice che possa essere, come dire, cautelativo per i diversi utilizzi. E allora ecco, così brevemente, applicando quello che diceva Francesco, abbiamo individuato una serie di porti pilota, Tolone, Genova, La Spezia e Olbia, e in questi 4 porti abbiamo indagato la matrice sedimento, colonna d'acqua e biota. Sono state individuate una serie di stazioni di campionamento e sono state programmate alcune campagne di monitoraggio. Tra l'altro in questo caso abbiamo anche contemplato, diciamo, l'impatto del periodo Covid. Brevemente le linee di evidenza che abbiamo individuato per quanto riguarda il sedimento, ecco, le vedete qua. Diciamo una serie ovviamente di analisi chimiche sui sedimenti, ora non sto ovviamente a dettagliare. Per quanto riguarda la linea di evidenza dei saggi biologici, dei bioessay, abbiamo individuato una batteria, diciamo, di specie e sempre per la parte sedimento, diciamo, una linea di evidenza legata al biota, che era quella ovviamente delle comunità bentoniche. Per quanto riguarda invece la colonna d'acqua, le linee di evidenza erano soprattutto legate, anche in questo caso, alle analisi chimiche e in particolare ai metalli in traccia nella frazione disciolta, e una serie di parametri aggiuntivi che però di fatto poi non sono stati elaborati in modo integrato nel modello, perché ad esempio gli accumulatori passivi che abbiamo utilizzato sono stati utilizzati soltanto nel porto di Olbia, così come anche altre misure dal punto di vista chimico-fisico o anche riguardo la correntometria. Quindi questo per quanto riguarda le analisi chimiche della colonna d'acqua, oltre poi a altre linee di evidenza, sempre per diciamo, legate alla colonna d'acqua, anche se come dal punto di vista più biologico, e cioè il bioaccumulo nei mitili e nei pesci e i biomarker nei mitili e nei pesci. Quindi in sostanza, ecco, sono state individuate delle stazioni in ogni porto, generalmente almeno 3 stazioni, 2 soggette a impatto ed una di controllo, diverse campagne di monitoraggio, capitalizzando anche, diciamo, i risultati di campagne di monitoraggio di altri progetti del marittimo come il Sedriport. E ecco, tutto questo ci ha portato ad alcune migliaia di dati tabellati secondo appunto ciascuna linea di evidenza. L'elaborazione con il software dedicato proprio per Geremia, con le sostanzialmente 6 linee di evidenza che sono state ovviamente non tutte in tutti i porti, ma insomma diciamo quasi in tutti i porti, tutte 6 linee di evidenza, e quindi tutto questo ha portato, secondo il modello che faceva vedere Francesco, alla definizione appunto di una classe di rischio, una classe di rischio nei 6 porti. Qui vedete, diciamo, i vari colori, praticamente per il porto di Olbia la situazione è molto confortante, il pericolo è piuttosto basso o comunque assente in tutte le stazioni. Per il porto di Genova abbiamo qualche evidenza di pericolo medio. Per la Spezia, ecco, compare qualche situazione un pochino più, come dire, critica, con nell'area più propriamente portuali del Molo Fornelli, una parte interna al porto, e per il porto di Tolone lo stesso abbiamo, ecco, un paio di situazioni un pochino più critiche come rischio medio. In sostanza, e qui vado verso la conclusione, così questo progetto ci ha evidenziato nei diversi porti, ecco, la possibilità di confrontare, come dire, la qualità ambientale, diciamo, non solo del comparto acque, non solo del comparto sedimenti e non solo del biota, ma di tutte queste matrici assieme, portando poi alla fine un indice integrato che ci dà una valutazione sicuramente un pochino più rappresentativa, ecco, del grado di qualità di questi ambienti. E quindi l'approccio weight of evidence è sicuramente fondamentale per definire la qualità di questi ambienti, soprattutto di quelli più complessi, e valutare i possibili rischi. È uno strumento utile, diciamo, se non indispensabile, per sintetizzare, come già diceva Francesco, una grande mole di dati e soprattutto eterogenei. In questo caso 4.200 per Olbia, ad esempio 3.600 per Genova, no? E così anche per gli altri porti. E il modello sviluppato quindi a partire dal software che attualmente abbiamo utilizzato, come vi dicevo prima, all'interno proprio della normativa sui dragaggi in Italia, quindi dove questo software è anche, come dire, ufficialmente utilizzato per 2 linee di evidenza in quel caso, cioè la chimica e l'ecotossicologia dei sedimenti, però è un software aggiornabile e adattabile a diversi contesti e sicuramente anche, diciamo, gli accumulatori passivi, diciamo, avranno a breve, come dire, una loro collocazione importante per questa, diciamo, valutazione integrata che tenga conto anche di questo, diciamo, nuovo, per così dire, almeno dal punto di vista, ecco, più normativo, approccio, diciamo, che oggi appunto come dire, anche voi dibattete, no? in questo contesto. Grazie, io ho terminato.
Grazie Dav. C'è adesso? Non c'è Gaetano. Ah, ok. Miguel.
Okay. Just to do the last presentation from the morning. Another presentation. Okay. Okay, just to do the last presentation in the morning. Again, a presentation online by John McGord from the laboratories in Ireland associated with ChemCatcher passive sampling. John, are you online listening us? Can you check if we have John McGard online?
Hello.
Okay, loud and clear now.
Can you hear me? Hello.
Yes, are you hearing us?
You're coming in loud and clear.
Yeah, loud and clear.
Sorry about the little bit of a delay. Now, I'm just going to share my screen. I'm not overly used to Zoom because we normally use Teams. So I hope this comes up okay. You might tell me if it's all right.
Okay, we are seeing.
You can see my screen. Okay, so am I okay to go?
Yes, please.
Okay. Apologies for the delay. My name is John McGrath. I work for a company called TE Laboratories based in Tullow in County Carlow in Ireland. And we're an analytical laboratory. We're an environmental laboratory. We analyze water samples for utilities and for industry. And a number of years ago, we were involved in a number of different projects, but the University of Portsmouth, whom Gary, I think, spoke maybe earlier there in relation to the presentation, he introduced us into ChemCatchers, and really from that, we've developed a commercial ability to sell ChemCatchers worldwide. So in reality, I am a salesperson, so I'm probably the least qualified person to speak at this particular meeting. However, what I do in the group here is I interact between the client, being the end user, the customer that is using whatever it is we're selling, plus also the technical aspect of it, whether that is support from internally within the laboratory here, from our own knowledge that we've built up over the last 10 years or so, or leaning on the university if it's something that is slightly unusual. Our client base tends to be either academia or government type of organizations, and they fall into the likes of environmental groups like environmental agencies or food authorities. Or the second type of grouping that we would see from time to time are water utilities, which they are kind of semi-state, but they are commercial utilities. So the presentation that I've put together here is based on 3 different case studies that we have done. And I've chosen those type of customers where there is an end user. The thing with passive sampling is a fantastic tool, and I wish it was used a little bit more. Obviously, and I saw earlier on in the presentations, there was a discussion there in relation to legislation. There was no legislation that was requiring the groups that I'm going to present to you to actually do passive sampling. However, they actually did have a commercial reason to do that, and I'll try and explain why they went about that. Just one thing I just want to say, please feel free if you have any questions, stop me at any stage. And also, if I'm just keeping an eye on my clock here, and if I run over, please feel free to stop me at any stage. Being an Irish person, we're used to talking quite a bit. If I don't get through all the case studies are available on the ChemCatcher's webpage. Please feel free to go to them. So the presentation just explains, we do normal grab sampling for our client base, our existing client base. And if you're monitoring a particular component, be it caffeine, or be it a drug that has come out of a pharmaceutical treatment plant, or a pesticide, or anything like that, it has maybe fluctuations within relation to the water course that we're monitoring in due to rainfall events or application or episodic spills that may happen. And that, you may see a pattern like that. When we take grab samples, you might miss the peaks and troughs because you're just taking it at a single space in time. Also, the limit of detection for that particular component, whatever it is that we're monitoring, may be well above what our limit of detection is on the instrumentation. So the grab sample it's a less than result. We might put in a composite sampler where we sample for a number of periods of days or hours. And yet again, we may miss these larger peaks. So what passive sampling does for us is it includes over a longer period of time, and we do a time-weighted average. And that time-weighted average in many of the cases that we'll show here is above our LOD, and that gives a lot of information to our end user. You've discussed this earlier on, but the things about passive sampling that I really like to offer to the customer, firstly, it is that prolonged sampling period, maybe over a duration of 14 days would be the average. The other thing I really like about them is no requirement of power. The devices that we use, which is ChemCatchers, and I appreciate there are other units out there, they are reusable. This is another key thing, is that rather than just taking that grab sample where we do 1 or 2 liters, we're possibly looking at 1,000 liters over a period of time. And that allows us to look at lower LODs, limits of detection, and also maybe to detect those episodic events that happen, whether it's a flash flood or whether it's an accidental spill into a watercourse. Again, these have been widely discussed. Like, we break down our components that we monitor into either emerging contaminants or legacy issues. So the ones that I'm going to speak about today are really the acid herbicides and pesticides. This is what the ChemCatchers looks like. Many of the people possibly on the call here have seen the ChemCatcher cage before, and the actual little housings holding the membranes on site. And that's what the deployment looks like. This here is actually a plate that we use instead. It's a lower cost version. The ChemCatcher cage is quite expensive, but there's a low cost version in using a plate. And as you can see, we just have a little marker in the water course. On one of the case studies, they actually use a net bag, a mesh net bag, that is a laundry bag that we use on a number of sites, and it's a lower cost option again to deploy the equipment. So moving very quickly into the case studies, and as I say, I'll touch upon these. Many of the people online may know of Teagasc as Agricultural and Food Development Authority here in Ireland. And the question that they were trying to do is they were trying to understand pesticide applications within the watercourse. So Teagasc have 6 key regional points that they are monitoring within catchments. And in these catchment areas, they have automated equipment doing various types of analysis, like nutrient type of analysis. So they've hacked equipment for doing nutrient on real-time monitoring. What they wanted to do really in the deploying of the passive sampling was to understand about the process of how the herbicide got into the water table, into the water course, into the surface water. And they deployed within each of these 6 regional locations, they deployed a mesh bag with ChemCatcher housings in it. This particular study is really, really interesting in that they do it for the 12 months, where on a number of the water utilities that we do a similar study for, they actually start around this time of the year, around April, May, and they go all the way to November, which is the spraying season within most of the applications that we do. What Teagasc wanted to do was to develop practices to modify or minimize the loss of acid herbicides into the watercourse. And they were obviously looking for an alternative tool rather than using the grab sampling that they do alongside the passive sampling on these 6 sites. So just to briefly explain, MCPA is an acid herbicide that is widely used to kill weeds without harming the crop, and it's very much used near water courses. It doesn't bind to soil, and it's prone to leaching, especially with flash floody type of conditions, and it can end up very quickly in a water course. The half-life is up to 14 days up to 1 month, depending on the crop that has been treated and the amount of MCPA has been used. So the advantages of using the ChemCatchers or passive sampling device was obviously the monitoring, rather than taking that little quick grab sample that they do every month or so that they visit the site. They were able to monitor over a 14-day period. Equally, ChemCatchers was able to identify at a level that traditional sampling wasn't able to get to. They were able to get to lower LOD within monitoring of the acid herbicide. So Teagasc had divided the catchments into 2 different types of land types, a grassland catchment and an arable land type of catchment. And they wanted to see what the differential is in the spreading of the acid herbicide across the 2 different types of catchment areas. And then, as shown on the next slide, they developed these particular type of graphs in relation to rainfall. And then they put heat maps in relation to the different areas that they have done the monitoring on. So this is a grassland, and this is giving you an idea of the top. You have your rainfall event, and on here on the bottom of the graph, you kind of see we put this date line here to show when the actual spraying season kind of started. So within this particular structure, this particular graph here, you can see on the bottom one that the MCPA within the grassland, we got some very, very high peaks. Now, this is a longitudinal study that Teagasc are continuing today, and we were developing this information really for them so that they can go out and advise in relation to different ways of applying the acid herbicide to the different types of farmland. This particular site here, grassland, and this particular slide here is arable land. And as you can see, the MCPA isn't as prominent in relation to the arable land, and it just shows the different type of mechanism for the particular acid herbicide, whether it's MCPA or 2,4-D is another one that's quite commonly picked up upon within the different type of soil structures that you have. As I say, this is a continual study that we're doing, and we've done it for the last number of years. I'm giving you a very snapshot period, just showing the type of information that they are developing on a continual basis. Moving on to the next case study. This is Northern Ireland Water, who are a water utility up in the north of Ireland, and they use chem catchers to improve raw water within this particular catchment in Ballyrees. So in terms of being a water utility, they supply roughly around 560 million litres per day to the population in the north of Ireland. So it's quite a small in terms of actual water utility, but this particular case is quite interesting. So back in 2017, Northern Ireland Water were informed of, they received 3 enforcement notifications from the Drinking Water Inspectorate in relation to tests that the Drinking Water Inspectorate had carried out on the final drinking water coming from the Ballyrees drinking water plant and Derrick plant in relation to identifying MCPA within those particular final drinking water at a level that it shouldn't be there. So what Northern Ireland Water did in 2018, they had to identify a way of how can we modify or get improvements within the drinking water quality. They used chem catchers to identify sources of the MCPA and try and deal with the issues of exceedances. Obviously, there is an option there to maybe put in technology to remove MCPA within the drinking water plant. However, that was cost prohibitive, and there's a number of other issues in relation to that, and also there is the timeline. So what Northern Ireland adopted was a educational type of approach. So they were going to monitor the different water courses that they had within their catchment areas, and then try and go out to the farmers within that particular catchment and ask them to modify the way that they actually deployed the acid herbicide. And they used chem catchers because they were doing fortnightly sampling, grab sampling, but that misses those rainfall events, those episodic spills that happen from time to time in relation to the monitoring of MCPA. Also, they have a certain capacity within their sampling people to actually physically go out to these sites and advise farmers. Chem catchers really, firstly, it's very, very cost effective, or passive sampling, I should say. It's very cost effective. They put it out and come and retrieve it within 14 days and get an idea of what the results are like. So Ballyrees is up, there's Northern Ireland, just in case anybody doesn't know, at the top half on the northeast of Ireland. And this is the particular catchment area that we were monitoring. The catchment area is quite large. However, the monitoring points are within this small category here. And this is the type of results. The little dots down here at the bottom, they are the various monitoring at the different, they put in 6 different chem catchers, 6 different catchment areas. And the little dots here are the spot samples. And then these are the chem catcher results. So as you can see, the LOD for MCPA was at 0.1 micrograms per litre. But the actual chem catcher results are well above that. So even though the catch samples in a lot of the cases, those grab samples were beneath the limit of detection or the actual limit for MCPA, we did find a number of situations where they're there at quite high levels. And as I said, Northern Ireland Water took the approach of liaising with the farming community to maybe, rather than using a lance behind a tractor to spray the MCPA, they told them they used a weed wipe which is like a large rotor on the back of a quad bike that's pulled across the land to actually wipe across the surface of the actual rushes or the weed and to bind itself onto the weed, as opposed to a continuous spray. So I say they picked, there's 5 different locations here that they were monitoring small little rivers and tributaries, and to develop those type of results that we've seen. And from all that, over the period of the season, they were able to develop these nice little heat maps of areas that they've had problems. As I said, they identified hotspots, and they targeted those hotspots by going back out and informing the farming community that they had identified high loading within the acid herbicide. And they've continued this. This started back in 2018.
Okay, see you Monday.
Okay,
Oops,
so
don't interrupt. Martin,
okay,
you have your micro. Oh, thank you. John, I use this interruption to say if it is possible to finish within 5 minutes, we'll be
yeah,
okay.
absolutely. What I'll do is I will just finish on this one then, and I'll leave you with the last presentation. As I say, the slides are there, and it is on our website. So they were able to develop these little heat maps and really to identify areas to go into the farming community and advise them. This little last slide this really was a key thing with the monitoring of chem catchers and use of passive sampling for Northern Ireland. There was a particular accident that happened back in 2018 while we were doing the monitoring, and a farmer had an accident in transferring some of his load to his acid herbicide load to a particular land where he was going to use it to spray, where he actually dropped a lot of his tanker into a nearby watercourse. Unknown to him, there was a chem catcher a little bit downstream of where he'd actually had this particular accident. However, he was very vigilant in that he picked up the hotline and he informed Northern Ireland Water that he'd had this accident and that this had happened. And what we found was, in the particular situation, we found during that 2-week period, a massive increase in the amount of MCPP that was actually detected from that particular accident. And this kind of validated it for Northern Ireland, that passive sampling caught that episodic event where it was just an instance, an accident that had happened and actually had dropped material into the watercourse. I will leave the last case study in order so that I don't run over time, and I just explained to the audience that basically the last particular case study is in relation to the monitoring of TBT and TNT within the Baltic Sea, and this is basically from armaments that were dropped during World War I and during World War II. However, the idea was that we were trying to monitor, because of developments from tourism and also wind turbines, they are starting to use this offshore area again, and there was a lot of movement of soils and lands, and during the course of this particular development, they used chem catchers to identify any potential losses of pollutants from moving old armaments that were present in the Baltic Sea. And in particular, it was TBT was the main one that we spoke about. However, as I say, this case study is written about in great detail on our website, and as are the other two that I've rushed through very quickly. So I'm happy to hand back to you there, and you can take control of the screen. I'll stop sharing.
Thank you, John. Very nice presentation with the 2 case studies that you present, and another one that we for sure will see it on the web. Now we are going past to another phase of the workshop with a discussion section. So please, I will call Lee and T. Poland as facilitators for this discussion. I would like also to do an announcement on behalf of the organization. There will be at the end a lunch at the ground floor after the meeting finished. Okay.
Well, thanks very much. First of all, I would like to thank Marco and the UNICAD team for hosting us. We were really well looked after, and that's been great to have the event at this beautiful CC. And also thank you to all the speakers today. It's great to hear all the the wonderful things that's happening around the world of plastic samplings in terms of DGTs. And on the very interesting case study as well. So these sessions, the next sessions is going to be open for discussion. So we hope to have lots of interactions between our audience here in presence and also online. I don't know whether anyone can monitor the questions online, so we can maybe pull if they have any people having questions or anything to interact with us, keep an eye on that, and we can
perhaps we could have that on the screen up here, the Zoom meeting, which perhaps.
Okay, so first of all, any comments or any questions, any things that our attendees would like to talk through, or to if they want to raise their hand? Well, if not, Miguel, maybe there's a microphone for you to.
Participants are okay, mainly Francisco Regoli. Francesco, are you?
Sento gli oratori principali.
Ok.
Sì, la sento, però non sento le domande. Mi sentite?
Francesco?
Sì, Marco, mi senti?
Sì, ti sentiamo. Vuoi intervenire?
Io sento, non ho capito se c'è stata una domanda, perché sento parlare.
No, stavamo invitando quelli che sono online, perché adesso c'è la tavola rotonda. Ah, c'è Miguel che ha fatto una domanda per te, forse. Adesso dovresti sentirlo, te la sta per fare.
Okay. Okay, very interesting, the approach of weight of evidence. I would love to read it more carefully. I just have a question related in if you want to evaluate or to assess for a metal that already exists in nature. Well, all metals exist in nature. If you take into account the natural levels, and how do you take that from the evaluation? Thank you.
Sorry, Miguel, can you repeat the last part, because I didn't hear you very well.
Okay. Taking into account.
Yes, now I hear you very well. Taking into account.
I've changed microphone.
Okay, thanks.
Taking into account the weight of the evidence process that you have showed, for example, for assessment of a certain metal, did you took into account the natural levels, and how do you process the evaluation with the anthropogenic versus natural contamination?
It depends, Miguel, if you are referring to the levels in abiotic matrices or in organisms. Concerning the first one, if we are looking to natural levels and if these levels are available, you can easily set, let's say, your reference value as those that you know as basal levels. So concerning the line of evidence on metals or chemicals in general in sediments or in seawater, you always need to have a reference guideline which can be international or adapted according to local values. If we are moving to the biological compartment where it is much more complex to have such kind of baseline values, also according, for example, to seasonal variability that organisms can exhibit in levels of pollutants, we always need to have an appropriate reference or control site toward which the observed concentrations are normalized in terms of variations.
Okay, thank you for clarification.
Thank you very much for that, Francesco and Miguel. Anyone else has got any questions regarding the previous presentations or for the open discussions in general?
If I can add, if I can just add a comment on DGT, can you hear me?
Yes, sure. Go ahead, Francesco.
Even taking the opportunity of the answer made by Miguel, I will say that should we work in including the DGT in this automatic and model of weight of evidence concerning the relevance or the weight of the chemicals, we don't need to adapt new things because we already have a certain body of evidence concerning the toxicity of different chemicals. We are working toward emerging pollutants for which, on the other side, this kind of evaluation are much more lacking. So we still have a lot of things to know. The important thing would be to define maybe those that you consider as basal levels and those above which we might consider that an anthropogenic impact is occurring. That is could be one of the way to proceed toward the definition of scales.
Okay, thank you very much, Francesca, for that. I guess that maybe the main question is what now? What's the next step? Basically, I'm sure that from Gary's talk this morning, say what are the future steps? What should we be doing? Are we looking at to have passive samplers, specifically if we're talking about DGT, to be used in compliance and the regulatory context to under the framework directive? We have presented lots of case studies, I guess, and some are more monitoring, some a little bit more regulatory in the case of French partners. but obviously they are, we recognize there are some gaps. We have identified those gaps. I'm not sure the levels of interest from what the attendees at the moment, whether there are anyone from the policymakers or regulatory bodies that's attending the conference this morning. Maybe it's very useful to hear from their point of view to see what they think we are missing. I think our bunch of scientists, we are very enthusiastic. We can do lots of things. The sky is the limit, I guess. So we are very enthusiastic, but it will be good to hear if there's anyone wanting to share their thoughts on that, in particularly under the compliance and regulatory context.
Perhaps if Ramir could share with us their learning experience through going through this and actually getting some compliance and legislation tied in with DGT work. Would that be okay? Sorry to put you on the spot.
Natalia, you want to comment?
Yeah, going this same direction you are pointing in, I would like to know, because we saw this morning, like both in France and in Italy, passive sampling have been included in their directives or in their legislations, both for dredging or also for monitoring of the marine environment. And I would like to know, like, if we could take the chance of talking, I don't know, with people from other countries. Like maybe I saw that Keys was connected, Martin, some people from the EU and Spain also. So I don't know if any of you are aware if in the other countries there have been any movement to try to include passive samplings in the guidelines of your countries. So that would be nice to learn from your experiences.
Would it?
Yeah,
If
I think
Ramir, could
Brendan
you-
has
Oh, you have a hand
wanted
up.
to talk.
Sorry.
Thanks, Natalia. I think that's a very important question. It would be good to get that overview from other countries, because again, as I was trying to promote earlier this morning, the work of Norman is really trying to get that information together to promote the activity or to show how widespread the countries are using sampling. I wasn't aware until today that Italy had also brought it into their legislation. So maybe, do you have information on how that happened, or is there somebody there that would be able to explain how that happened in Italy?
Up to now, there is no inclusion of passive sampling and DGTs in the regulation, but we are working with ISPRA. We are Mr. David Pellegrini, because he's the leader of the activities on ports in Italy and on dredging and so on, because we try to include the DGTs in the guidelines for dredging activities in together with biomonitoring with mussels. And I think some results have been already obtained, but I don't know precisely what is the level of this inclusion.
Okay, thank you. I misunderstood Natalia when she said that it was adopted into legislation. Maybe as well, T, just for 2 minutes, a little bit of context. There was a passive sampling meeting in Utrecht about a year ago, and there were presentations from the EEA and from the EU around the how monitoring is working. And it was pretty clear at those meetings that monitoring spot samples is working, but it is very variable, and it is often not reaching the levels that would be desired to meet EQSs. So I think there was a very much a conversation where it was left open that as a collective community, if we can make very strong cases, that passive sampling, I think, would not be thrown out so quickly. If it helps to improve the data sets, if it helps to improve the monitoring coverage, if it helps to improve the LODs and LOQs, then I think when people get together and use it collectively, I think it would be very it would have a very strong case. And the second thing that came from other discussions was that there seems to be still a perception at a regulatory level anyway, that how are we proving that passive sampling is working? So we're all doing this monitoring to show that we can measure levels of pollutants in the environment. But doing it at a very base level of doing spiking type exercises, I think is going to be something that it will be needed to be done to be very convincing, to show that the passive samplers are actually picking up what is in the water column. So that will probably involve spiking water samples at various levels to prove then that the corresponding passive sampling device can be modeled or can be shown to be in the same order of magnitude and can be able to model back to the concentration in the water. And I think that perception is out there that is not feasible at the moment, and it is one thing that is holding back passive sampling. Okay, thank you.
Thank you, Brendan, for your additional on that. Isabel, you have a question. Oh, oops.
I'm going to try to answer to Lee questions. A little, I try. Okay, so in France, we have tried to use passive samplers since a long time for monitoring in West Indies, overseas department. And we use also DGT and POSIS and SBSE in the framework of project to identify which among the emerging contaminants should be interesting to monitor. So it's prospective monitoring. So to identify in the framework of the WFD the specific pollutant. Okay, so we have a project that is called Emergency with several points all around France, and we will do it also in the overseas. There is also, we spoke about it yesterday, for the monitoring of, in the framework of the development of, well, I will say wind farm, but it's more than wind farm, okay? And we, for the ministry, IPREMER is in appui, I don't know, is in advice, provide advice and recommendation on how we can monitor the contaminants that are linked to the implantation of such wind farms. So we identify a lot of contaminants of interest. Among them, there is chemical contaminant, metallic contaminants, and organic also. And we recommend also DGT for the monitoring and for the, for the monitoring and the characterization of the contaminant. That's it, maybe.
Thank you.
Thanks very much, Isabel, for the additional informations on that. Miguel, you would like to?
Following the same situation that Isabel was explaining and Brandon was pointing, I know that for food safety audits from the European community, when you are not using a method that has a directive or that is indicated by European community, you need to do a proof that it works. And they accept if you prove it in numbers during the audits. They also sometimes need to have historical information. The issue of historical information, I think it has been already used in Water Framework Directive. For example, in Portugal, we do not monitor a lot of organic compounds because we proved in the first 10 years, I think, we have not found it. So if you have not found it, we do a larger time scale monitoring. My question or my comment, it will be using case studies for each country, because I need to do within each country. Do you think that it will be feasible to present that as areas that work, the use of DGTs to monitor and extend and apply to the extension to the other sides of that member state? Do you think it's feasible, Brandon?
Yes, that's the sort of approach that through the Norman network that has been taken. That is the hope. And with the IPSW, so the International Passive Sampling Workshop, there is an aim to pull together a position paper, which is very similar to what you describe, I think, in content, pulling together case studies, pulling together information to try and promote the activity, yes. So I think that is the approach. I think there has been hundreds of millions of euros spent on passive sampling projects, individually in countries and around Europe. And I think pulling together the information is the next logical step to try and either move it on or to at least make some decisions as to its applicability.
Thank you, Brendan. Natalia, you got another question?
Yeah, I have a question. Maybe someone from the audience can answer it, or yeah, just in like the ones connected online. And I would like to know, like, for example, in the case of some contaminants, the directive recognizes the difficulty of measuring them in the water column, like in the dissolved state or total dissolved concentration. So they move, or they accept it also other matrices recognizing that, like biota. So I would like to know if you consider like the watch list is going to open the opportunity for passive samplers to be accepted, maybe because as an alternative to spot sampling, because first of all, you will need to measure these compounds in a lot of water masses, just to know what are the background levels in this country, and even to know if those compounds are of relevance in each of the member states. But also because for the case of the watch list, there is not an EQS. So it's just saying they propose techniques, or they propose the best method to measure them and what is the reliability and accuracy of those results. So I don't know if any of you think like maybe the watch list will be a good alternative to move from the spot sampling approach that probably is going to still be used for some compounds, maybe to the passive sampling one. I don't know if have you given a thought about it?
Thanks, Natalia. That's a good point. Anyone have thought on that, using passive samplers to monitor compounds on the watch list? No.
I think that it's, I think that that is a good logical sort of step. I think Miguel has identified that in Portugal, doing monitoring allows you to be then selective in what compounds you measure in the future, whether that be watch list or whether that be other compounds that we currently don't know maybe exist in our waters. So passive sampling has a good application within that area or field of research. And also that continual monitoring using passive sampling, you have the ability to also monitor trends of these compounds. So using the combination of occurrence, the potential for risk, maybe relative to a PNEC where threshold, where EQSs don't exist, combined with the trend direction may support you in your monitoring program. It doesn't make it compliance monitoring, but it does help you in the future.
Thanks, Brendan. Anyone else having further comments for the discussion? Gary, yes, sorry.
Is that working? Yeah. So I think from what Brendan was saying earlier, I mean, from my experience and working with water companies and the Environment Agency, so I think we're moving away from from metals and thinking more in terms of organics now. So this was this kind of question that I posed earlier in terms of why do you want to use a passive sampler? Because if you just want to look at things that are on the watch list, you probably better just going out and taking some spot samples and seeing what's there. But I think if you then start to think, right, well, let's open it up and think about all those other different chemicals that are there. So I quite like, and we've done the same, and Brendan put that in his, I think it was probably like his last slide. So where would passive sampling fit in monitoring? And he put that in like that first bit. So you do some kind of screening, see what's there, does it appear, look at trends over the years, and then use that as an investigative tool to start with before you can then drill down and then go, right, we need to sample for these particular contaminants at this time of year. And this is in the case of the Environment Agency, because they do actually do stuff contrary to what people in the UK or England say about the Environment Agency. But then so that they can then prosecute, because they can't take a case to court with some passive sampler data that some prof from Portsmouth has done. So it has to go through their proper lab. But we've worked with them. So one example is we did some passive sampler work, although this was all done through the Environment Agency and Natural Resources Wales, but discovered some chemicals weren't supposed to be there, did some more passive sampling monitoring, drilled down, found out what those chemicals were. They then went out, did the gold standard spot sample, and then they were able to prosecute. So I think in terms of that, what do we want to use passive samplers for? We have to think quite cleverly in terms of where do we position those? So certain passive samplers might be useful for kind of investigative screening work. Things that are more robust, like DGT, it'd be better for, you've already got EQSs, so you know exactly when to deploy those. So I think we just have to be as a, and I mean, and I, you know, Keys is on this call. I've said, you know, we've spoken for many years about non-polar and how we integrate that into policy. So I think in terms of metals and then maybe the polar contaminants, we just have to think, where do we integrate the passive sampler in there? It's not the end. I mean, I like Brendan's one where he said, you know, even after 30 years, we can still say passive sampling is a complementary tool to spot sampling in terms of our monitoring. But that's on the monitoring level as where we can use passive samplers.
Thanks very much for that additional thoughts, Gary. And I think has been really useful discussions. I'm going to pass my seat over to Blanate for the closing words. Thank you.
Thank you very much, Thea and Lee, for that, and everybody for that. What, as you said, Lee, was a really interesting discussion. Thank you. And so now is the time where I have the job of closing the session, and I'm delighted to have the honor of closing this insightful conference and to do so on behalf of everyone in MONITOOL. Though before I begin, I would like to thank all my friends and colleagues in MONITOOL for their dedication, their commitment, their friendship and their humor over the last 6 years. It has been a privilege to join you on this journey. Okay, so to the business in hand. We have had the pleasure of a wonderful conference this morning, and we in MONITOOL would like to firstly to thank everyone who presented their work and shared their expertise with us. And secondly, in terms of preparing the conference itself, to echo Thea and colleagues, we would like in particular to thank Marco and all our colleagues here in Cagliari, to Anna and Stefania from DCU, to Marta and Vanessa from ITC, and everyone who contributed to getting ready for this session. Thank you. We'd also like to thank everybody here at T Hotel, especially our very talented translator, for enabling such a wonderful hybrid and multilingual meeting. And finally, we'd like to thank you all here for your thoughtful presence today and for your participation in the session we've just had. In preparing for today, we sent a questionnaire to all our attendees about what you'd find useful from today's meeting. And you came back to us and you asked us to explain the DGT technology itself, to compare it to other passive sampling technologies, and to explore its potential for things like emerging contaminants. You asked us to include discussion about calibration, standardization, and guidelines, and to consider how passive sampling, for DGTs in particular, might become more accepted and play a role in compliance monitoring in the future. So we hope that as we bring this meeting to a close, you can see how we shaped this morning to address all those valid, important aspects of DGTs and passive samplers. Natalia Montero demystified DGT use, and she showed how, with the robust protocols that we've developed in MONITOOL, DGTs are robust, reproducible, and cost-effective to use. Jean-Louis Gonzalez and Hao Zhang explored the breadth and the versatility of DGTs and how we're only at the beginning of the compounds that they can be applied to. Laura Durante gave us a wonderful insight into how DGTs can be successfully deployed to support efforts to remediate and maintain a UNESCO wetland. And similarly, Francesco Reggioli and David Pellegrini demonstrated how DGTs can be included as an additional line of defense towards an integrated environmental risk assessment in port areas, particularly for the evaluation of the water column, and also flagged how these areas should be routinely monitored in the future to accumulate evidence of their status. Brendan McHugh provided an insightful context of the path towards passive samplers having such a role in compliance monitoring, considering how projects such as MONITOOL have answered many of the research questions posed in research years and highlighted possible next steps on that path for us. Both John McGrath and Gary Phones shared a number of case studies with us where they applied other passive samplers, particularly chem catchers, to give a broader perspective of the breadth of analysis and application areas where different passive samplers can be deployed. And Gary also asked us what next, and he challenged us to consider if we are really carrying out full chemical analysis, particularly for compounds like polar organics, as well as expanding to explore forever chemicals like PFAS, antibiotics, and compounds like that. How, who, as Natalia correctly said earlier, is our mother of DGTs. She presented a really important list of the questions that still remain to be answered, the research that still needs to be carried out. And in the final discussion, Thibault posed Gary's question to us all again, highlighting that gaps in research do exist and that we're very enthusiastic to explore the research in these gaps. And so this is less of an end and more of a call to stand on the shoulders of MONITOOL, or I agree it's going to be MONICOOL, I think is a better moniker for us going forward. And we should continue to expand our research and explore how and for what we use DGTs. And so we in MONITOOL, we bring this meeting to a close, not as a final conversation of this collective MONITOOL community, but just a final meeting of this chapter. And we look forward to beginning the next chapter and hearing more about that in Paris in October in that beautiful view on that 25th floor. And so with that, I invite those of you who are here in person to continue our conversations over lunch, and those of you online to continue these conversations in your home institutions as well. Thank you very much.